Hey guys, tonight we're diving into something darker than your browser history. The world of designer drugs, specifically Bromazolam, the sneaky little pill that's quietly replacing Xanax on street corners and in medicine cabinets across the globe, not the pharmaceutical kind prescribed by your friendly neighborhood psychiatrist. I mean the sketchy, unregulated, potentially deadly kind that's flooding the black market like knockoff Gucci bags, except way more dangerous. So, before you get comfortable, take a second to like the video and subscribe, but only if you actually enjoy what I do here. A huge thank you to Jamie from Las Vegas who suggested this topic. Your curiosity is literally shaping tonight's content, and honestly, without suggestions like yours, this channel wouldn't exist. Leave a comment telling me where you're listening from and what time it is for you. Somehow, it's always 2 a.m. somewhere, and apparently that's when people make questionable pharmaceutical decisions. Also, we're now live on Spotify. Check the link in the description if you want to fall asleep to stories about substances that might keep you awake forever. Now, dim those lights, switch on a fan for that soft white noise, get comfortable, and maybe hide your Xanax prescription because we're about to make you paranoid about what's actually in those pills. Let's pause for a second. Have you ever wondered what happens when chemists start playing God with benzodiazepines? Did you know there's an entire underground market of research chemicals designed specifically to slip through legal loopholes? What makes Bromazolam different from regular Xanax? And why are people choosing a completely unregulated substance over the prescription their doctor would give them? How does a drug get from a Chinese lab to your neighbor's teenager without anyone noticing? Could you tell the difference between a real Xanax and a pressed pill containing Bromazolam just by looking at it? Would you survive taking what you thought was 2 milligrams of Xanax but was actually something 3 times stronger? And now, congratulations. You've just woken up in the strange, murky world of designer benzodiazepines, where the lines between medicine, recreation, and death are drawn in powder that looks exactly like what your doctor prescribed. The year is 2024. You have access to the internet, a cryptocurrency wallet you barely understand, and a desperate need for anxiety relief that your insurance won't cover. Good luck. Let's start with the basics, because if you're going to potentially ruin your life with a substance, you should at least know what it is. Bromazolam is a benzodiazepine, part of the same drug family as Xanax, Valium, and Klonopin, those little pills that turn your anxiety into a gentle purr instead of a screaming tornado. Except here's the twist. Bromazolam was never approved for medical use, ever. It was synthesized in the 1970s by pharmaceutical researchers who were basically playing chemical roulette, creating dozens of variations of benzodiazepines to see what stuck. Most got shelved. Bromazolam got shelved. It sat in research papers collecting dust for decades, a footnote in obscure chemistry journals that only nerds with too much time and questionable intentions would ever read. Then, somewhere in the 2010s, underground chemists discovered it again, realized it was potent, easy to synthesize, and not explicitly illegal in most countries, and thought, hey, let's sell this to people who have no idea what they're taking. It's molecularly similar to alprazolam, that's Xanax, for those keeping track, but it's longer acting and potentially more sedating, which sounds great until you realize more sedating is code for you might not wake up. The thing about Bromazolam is that it works exactly like you'd expect a benzodiazepine to work, which is both its appeal and its danger. It calms your racing thoughts, melts away panic attacks, turns social anxiety into something manageable, and generally makes the world feel softer around the edges. For someone suffering from genuine anxiety disorders, that relief is intoxicating. It's the feeling of finally being able to breathe after holding your breath for months. But because it was never put through clinical trials, never tested on humans in controlled settings, and never evaluated for long-term safety, we're essentially conducting a massive, uncontrolled experiment on the global population. You're the guinea pig, and there's no ethics committee monitoring the results. What makes Bromazolam particularly insidious is that it looks legitimate. Street dealers press it into pills that are identical to pharmaceutical Xanax. Same shape, same markings, same packaging. You could be a pharmacist with 20 years of experience, and you wouldn't be able to tell the difference just by looking. It's only when you send it to a laboratory for chemical analysis that the truth emerges. And let's be honest, nobody's doing that. People buy what they think is Xanax from their dealer, pop it before a stressful situation, and never question whether they're actually getting what was advertised. It's like ordering a burger and receiving mystery meat that looks like beef, tastes sort of like beef, but might actually be something created in a laboratory that's never been tested for human consumption. Bon appétit. The chemical structure of bromazolam includes a triazole ring, which is what makes it a designer benzodiazepine. By adding or removing specific molecular groups, chemists can create substances that have similar effects to controlled drugs, but technically aren't the same compound. It's pharmaceutical sleight of hand. And because drug laws typically ban specific molecular structures rather than entire classes of compounds, these designer drugs slip through legal loopholes like water through a net. By the time lawmakers identify bromazolam as dangerous and move to schedule it as a controlled substance, chemists have already moved on to bromazolam's cousin, or nephew, or twice-removed molecular relative. The game never ends. So why should you care about some obscure benzodiazepine that you've probably never heard of? Because it's everywhere. It's in the fake Xanax bars being sold at parties, in the pills your friend bought online, in the anxiety medication being shipped from overseas pharmacies that don't ask for prescriptions. It's hiding in plain sight, disguised as something familiar and safe, and it's causing overdoses, hospitalizations, and deaths at rates that are climbing every year. Welcome to the world of designer drugs, where everything looks legitimate until it kills you. Welcome to the wild west of pharmacology, where chemists tweak molecules just enough to create substances that technically aren't illegal yet. These are called research chemicals, or designer drugs, and they exist in a legal grey zone that makes both law enforcement and poison control centres want to scream into pillows. The game is simple. Take a controlled substance like Xanax, change its chemical structure slightly, add an atom here, remove one there, and boom, you've created something that has similar effects but isn't on any banned substances list. It's like when your favourite restaurant closes down and reopens next door under a slightly different name to dodge health code violations. Except in this case, the health code violations are your internal organs. Countries try to ban these substances, but by the time legislation catches up, chemists have already moved on to the next variation. It's pharmaceutical whack-a-mole, and the moles are winning. Bromazolam thrived in this environment. For years, it was completely legal to buy in many countries, sold openly on websites disguised as research chemical suppliers with disclaimers like "not for human consumption" winking at you from the bottom of the page. You could order it like you were buying vitamin supplements, except vitamin supplements don't come with a side effect profile that includes respiratory depression, amnesia, and potential death. The research chemical industry operates in a fascinating legal twilight. Companies based in China, India, and Eastern Europe manufacture these substances in legitimate pharmaceutical facilities. We're not talking about sketchy basement operations. These are actual factories with quality control departments, shipping logistics, and customer service representatives who speak perfect English. They advertise on clear web forums, have professional-looking websites, and accept credit cards. The only difference between them and legitimate pharmaceutical companies is that nobody's testing whether their products will kill you. These suppliers exploit international differences in drug laws. A substance might be illegal in the United States, but perfectly legal in China. So they manufacture it legally, ship it internationally, and let the buyer deal with the legal consequences on the receiving end. It's the ultimate form of regulatory arbitrage. And because these packages are small, unmarked, and shipped through regular postal services, they slip past customs inspectors who are looking for larger drug shipments. Your bromazolam arrives in a plain envelope labelled dietary supplement or industrial sample, and customs waves it through without a second glance. The not for human consumption label is the magic shield that protects these companies from prosecution. As long as they claim the substances are intended for laboratory research, they can argue they're not responsible for how customers use them. It's the drug equivalent of selling someone a baseball bat and saying, "Well, we told them not to hit people with it." Everyone knows what's really happening, but the legal fiction is maintained because it's easier than addressing the underlying problem. What makes this particularly dangerous is that these research chemical suppliers don't just sell one substance, they sell dozens, sometimes hundreds, of different compounds. Bromazolam is just one option in a catalogue that includes synthetic cannabinoids, novel stimulants, dissociatives, and psychedelics that have never been studied in humans. Customers can browse through offerings like they're shopping for shoes, reading descriptions that sound scientific but are actually just guessing about effects based on molecular similarity to known drugs. This compound is structurally similar to alprazolam and may produce comparable effects. Translation: we have no idea what this does, but it probably won't kill you immediately. The business model is brilliant in its simplicity. Produce chemicals that mimic the effects of popular illegal drugs, sell them legally as research chemicals, and when governments finally ban them, simply switch to a slightly different molecular structure. The profits are enormous, the legal risk is minimal, and the casualties are someone else's problem. It's capitalism at its most ruthlessly efficient, and bromazolam is just one product in an ever-expanding catalogue of substances that exist in the space between medicine and poison, legality and criminality, safety and catastrophe. Once upon a time, if you wanted anxiety medication without a prescription, you had to know a guy who knew a guy who might sell you real pharmaceutical Xanax at markup prices. Then the internet arrived and improved everything, depending on your perspective. Darknet markets exploded, cryptocurrency made anonymous transactions possible, and suddenly anyone with a laptop and mild criminal ambition could order drugs from overseas. But here's the problem that became bromazolam's opportunity. Real Xanax is expensive to obtain illegally. Pharmaceutical supply chains are monitored. Pills have serial numbers. It's risky to divert prescription medications at scale, so enterprising drug dealers thought, what if we just pressed our own pills? And thus began the era of counterfeit Xanax, little white bars that looked identical to pharmacy pills but were filled with whatever the manufacturer decided to put inside. Sometimes it was actual alprazolam. Sometimes it was fentanyl, which killed people. And sometimes it was bromazolam, which was cheaper, legal to source from Chinese chemical suppliers, and close enough in effect that most users wouldn't immediately notice. It spread through the black market like a virus, pressed into fake Xanax bars, mixed into other drugs, and sold to people who had absolutely no idea they were taking an untested, unregulated research chemical. The economics of counterfeit pharmaceuticals are staggering. A kilogram of bromazolam powder can be purchased from Chinese suppliers for a few $1,000s. That kilogram can be pressed into hundreds of thousands of pills and sold for hundreds of thousands of dollars. The profit margins are obscene, and because bromazolam was legal to import in many jurisdictions, dealers weren't even risking serious criminal charges for possession of the raw material. It was the perfect storm of profitability and minimal legal risk. The pill pressing operation is surprisingly sophisticated. Dealers purchase industrial pill presses online, the same equipment legitimate pharmaceutical companies use, for a few $1,000s. They buy pharmaceutical-grade binders and fillers. They obtain dyes to color the pills correctly. They even purchase molds that create the exact shape and stamping of authentic Xanax bars, including the Xanax imprint and the breakable score lines. The final product is visually indistinguishable from the real thing. A pharmacist couldn't tell the difference without chemical testing. Neither can you. But here's where it gets truly dangerous. Consistency. Pharmaceutical companies have strict quality control. Every pill contains exactly the amount of active ingredient stated on the label. Counterfeit pill operations have no such standards. The person mixing bromazolam powder with binders might be eyeballing measurements. The powder might not be distributed evenly throughout the mixture. One pill might contain 0.5 milligrams, the next might contain 5 milligrams. Users have no way of knowing. They take what they think is their regular dose and end up unconscious for 18 hours or in the emergency room with respiratory depression. The distribution network for these counterfeit pills is vast and decentralized. Some dealers sell directly through darknet markets, shipping pills internationally in stealth packaging. Others distribute through traditional street-level dealers who genuinely believe they're selling pharmaceutical Xanax because that's what they were told by their supplier. The pills pass through multiple hands, each person adding their own markup until they reach the end user who pays $20 for a bar they think is legitimate medication. Social media accelerated this market exponentially. Instagram dealers advertise openly using coded language and emoji. Snapchat dealers post their inventory daily. Encrypted messaging apps like Telegram host channels with thousands of members buying and selling drugs like it's an Amazon marketplace. The platforms periodically crack down, but dealers simply create new accounts. The game of enforcement whack-a-mole continues, and the Bromazolam keeps flowing. What started as a niche research chemical has become the backbone of the counterfeit benzodiazepine market, and most users taking it have absolutely no idea what they've actually consumed. Time for a brief chemistry lesson that won't put you to sleep, ironically, because we're talking about a substance designed to do exactly that. Bromazolam belongs to the triazolobenzodiazepine subclass, which is just a fancy way of saying it has a triazole ring fused to a benzodiazepine core. If that sounds like gibberish, just know this: that specific structure makes it particularly good at binding to GABA-A receptors in your brain. GABA is your brain's chill-out neurotransmitter, the one that tells your neurons to calm down and stop firing like it's the 4th of July. Benzodiazepines enhance GABA's effect, turning down the volume on anxiety, panic, and seizures. Bromazolam does this too, but with some key differences. It's estimated to be roughly as potent as alprazolam, milligram for milligram, but it has a longer half-life, meaning it stays in your system longer. That sounds like a bonus, until you realize it also means the sedation lingers, stacks up if you take multiple doses, and increases your risk of doing stupid things for extended periods. The real danger is that most street Bromazolam isn't pure. It's mixed with fillers, pressed into pills with wildly inconsistent doses, and contaminated with who knows what from sketchy labs operating without any quality control. Let's break down what actually happens at the molecular level, because understanding the mechanism helps explain why Bromazolam is both effective and dangerous. Your brain is essentially an electrical network with billions of neurons firing signals constantly. GABA is the brake pedal on this system. It's an inhibitory neurotransmitter that slows things down, prevents overstimulation, and keeps your brain from spiraling into anxiety or seizures. GABA-A receptors are protein structures on neuron surfaces that GABA molecules bind to, opening channels that allow negatively charged chloride ions to flow into the cell. This makes the neuron less likely to fire. It's like turning down the volume knob on your brain's electrical activity. Benzodiazepines don't activate these receptors directly. Instead, they bind to a specific site on the GABA-A receptor complex and change its shape slightly, making it more responsive to GABA molecules. It's like installing a turbocharger on your car's brake system. GABA still does the braking, but now it's way more effective. The triazole ring in Bromazolam's structure enhances this binding affinity, making it particularly potent. Even small doses produce significant effects because the molecule is extremely good at what it does. The half-life issue is critical. Alprazolam has a half-life of about 11 to 13 hours, meaning half the drug is eliminated from your body in that time frame. Bromazolam's half-life appears to be longer. Estimates range from 12 to 19 hours based on user reports and limited research. Why does this matter? Because if you take multiple doses before the first dose is fully eliminated, the effects compound. Take Bromazolam Monday morning, again Monday evening, and again Tuesday morning, and you're layering doses on top of each other. The sedation accumulates. Your coordination gets worse. Your memory becomes more impaired. You're essentially marinating your brain in benzodiazepine, and the cognitive effects intensify with each additional dose. Now let's talk about metabolites, because your body doesn't just eliminate Bromazolam unchanged. Your liver processes it through enzymes, primarily CYP3 or 4, breaking it down into metabolites that may or may not be active. Some benzodiazepines produce active metabolites that extend the drug's effects even further. We don't have complete data on Bromazolam's metabolic pathway because, again, it was never studied properly. But based on its structure, it likely produces metabolites that contribute to its prolonged duration of action. This means you might think the drug has worn off because the initial peak effects have faded, but metabolites are still floating around in your system, impairing your judgment and coordination without you realizing it. The purity problem cannot be overstated. Pharmaceutical-grade benzodiazepines are synthesized in controlled environments, using reagent-grade chemicals and precise procedures. Street bromazolam is synthesized in clandestine labs, using whatever precursor chemicals are available, often with impurities and byproducts from incomplete reactions. These contaminants can be toxic in their own right. One batch might be relatively pure, the next might contain residual solvents, heavy metals, or other unknown substances, and because there's no quality control, no testing, and no regulation, users are ingesting chemical roulette every time they take a pill. It's the molecular equivalent of eating at a restaurant with no health inspections, no ingredient labels, and a chef who learned cooking from YouTube videos. When bromazolam enters your body, it doesn't waste time with pleasantries. It crosses the blood-brain barrier, the bouncer that usually keeps random substances out of your brain, and gets to work immediately. Within 30 minutes to an hour, you start feeling the effects. Your anxiety melts away like butter on hot toast. Your muscles relax. Your thoughts slow down. Everything that was sharp and jagged becomes soft and blurry. Sounds nice, right? It is, which is exactly the problem. This is how benzodiazepines hook you. They don't just reduce anxiety, they erase it so completely that your brain forgets how to cope without chemical assistance. Physically, bromazolam is a central nervous system depressant. That means it slows down your breathing, your heart rate, your reflexes, and your decision-making ability. You become a human sloth, except sloths have evolutionary advantages and you just have impaired motor control. At higher doses, you start slurring words, stumbling around, experiencing anterograde amnesia. That's when your brain stops forming new memories, so you do things and have zero recollection afterward. It's like being blackout drunk but without the alcohol taste. And if you take too much, especially mixed with other depressants like alcohol or opioids, your breathing can slow so much it just stops forever. No do-overs. Let's trace bromazolam's journey through your body from ingestion to effect. You swallow a pill, or what you think is a pill containing a specific dose. The tablet dissolves in your stomach, releasing bromazolam into your digestive system. The drug is lipophilic, meaning it loves fat, which helps it absorb quickly through your intestinal walls into your bloodstream. From there, it circulates through your body, eventually reaching your brain. The blood-brain barrier, which normally protects your central nervous system from random chemicals, lets bromazolam pass through easily because of its molecular structure. Once inside your brain, it homes in on GABA-A receptors like a guided missile, binding to allosteric sites and dramatically enhancing GABAergic inhibition across your neural networks. The subjective effects kick in gradually. First comes a gentle wave of relaxation. That tightness in your chest from anxiety begins to loosen. Your racing thoughts slow to a manageable pace. Social anxiety that normally makes you hyper-aware of every word you say suddenly matters less. You feel more confident, more relaxed, more capable of handling situations that would normally trigger panic. This is the therapeutic window, where the drug is doing what benzodiazepines are supposed to do, providing relief from pathological anxiety. But the therapeutic window is narrow, and street bromazolam makes it impossible to stay within it. As blood levels rise, the effects intensify. Your coordination starts deteriorating. Fine motor skills become challenging, buttoning a shirt, typing on your phone, walking in a straight line. Your speech slows and may become slurred. Your reaction time increases dramatically. If someone throws you a ball, your brain processes the information seconds slower than normal. You couldn't safely drive a car or operate machinery because your brain is literally running in slow motion. Your judgment becomes impaired. That voice in your head that normally says this is probably a bad idea gets quieter and quieter until it's completely silent. This is when people make catastrophically poor decisions, texting their ex, making large purchases, getting into cars with strangers, engaging in risky sexual behavior. The part of your brain responsible for risk assessment is taking a chemically induced nap. Then there's the amnesia. Bromazolam, like other benzodiazepines, interferes with memory consolidation in the hippocampus. Short-term memories simply fail to transfer into long-term storage. You're conscious, aware, making decisions, but your brain isn't hitting the record button. Hours vanish into a black hole. You wake up the next day with text messages you don't remember sending, items in your shopping cart you don't remember ordering, and potentially consequences from actions you genuinely cannot recall. It's not that the memories are fuzzy or hazy, they literally don't exist. No amount of concentration or prompting will bring them back, because your brain never encoded them in the first place. The respiratory depression is the silent killer. Breathing is controlled by your brainstem, which monitors carbon dioxide levels in your blood and adjusts your breathing rate accordingly. Benzodiazepines suppress this automatic process. At therapeutic doses, the effect is minimal. At higher doses, especially combined with other depressants, your brainstem basically stops caring about maintaining adequate oxygen levels. Your breathing becomes shallow, slow, irregular. Oxygen saturation drops. Your lips and fingernails might turn blue. And because you're heavily sedated, you don't notice or care that you're slowly suffocating. You just drift deeper into unconsciousness until your breathing stops entirely. This is how benzodiazepine overdoses kill, not through direct toxicity, but by shutting down the automatic processes that keep you alive. Here's where things get terrifying. In a legitimate pharmaceutical setting, medications are dosed precisely. A Xanax bar is exactly 0.5 or 2 milligrams of alprazolam, pressed with inactive binders, quality tested, and consistent every single time. Street bromazolam? Not so much. These pills are pressed in clandestine labs using equipment bought off Alibaba and powder sourced from chemical suppliers who don't ask questions. The people making them aren't pharmacists. They're entrepreneurs with flexible morals and zero training in pharmaceutical manufacturing. The result is catastrophic inconsistency. One pill might contain 0.5 milligram of bromazolam. The next might contain 5 milligrams, or 10, or none at all, just filler. Testing has found pills sold as 2 milligram Xanax, containing anywhere from trace amounts to potentially lethal doses. It's pharmaceutical Russian roulette, except instead of one bullet, random chambers are loaded with grenades. Users take what they think is their normal dose and end up hospitalized because this particular pill happened to be 3 times stronger than the last one. There's no way to know without laboratory testing, which almost no recreational user has access to. So people just pop pills and hope for the best, which is insane. But here we are. The manufacturing process for counterfeit pills is where everything goes wrong. In a legitimate pharmaceutical operation, active pharmaceutical ingredients are measured with precision balances accurate to milligrams. They're combined with excipients using geometric dilution, a technique where small amounts of active ingredient are progressively mixed with larger amounts of filler to ensure uniform distribution. The mixture is blended in specialized equipment for specific durations to achieve homogeneity. Each step is documented, tested, and verified. Street operations have none of this. Someone dumps bromazolam powder into a bowl with filler, stirs it with a spoon like they're making cake batter, and hopes it's mixed well enough. It isn't. The result is called the chocolate chip cookie problem. Imagine making cookies where you want exactly 3 chocolate chips in each cookie, but instead of mixing the chips into the dough properly, you just kind of stir them around a bit and hope for the best. Some cookies get 10 chips, some get none, and one unlucky cookie gets 40 chips. That's what's happening with street bromazolam pills. The equipment exacerbates the problem. Industrial pill presses can exert tons of pressure and fill thousands of pill cavities simultaneously with remarkable consistency, when operated correctly by trained personnel using properly prepared mixtures. Street pill presses are often operated by people who learned from internet forums, using inconsistent pressure with powder mixtures that aren't properly prepared. The pills that come out look identical but contain wildly different amounts of active ingredient. Some are underdosed, providing minimal effects and leading users to take more pills, building false confidence about their tolerance. Others are massively overdosed, containing enough bromazolam to render someone unconscious for a day. There's also the problem of deliberate overdosing. Some manufacturers intentionally make their pills stronger than advertised because they want customers to have intense experiences that build brand loyalty. Those blue bars from that one vendor knocked me on my ass becomes a selling point rather than a safety concern. Users chase the strongest pills, not realizing they're playing with exponentially increasing risks. A pill advertised as containing 2 milligrams might actually contain 6 or 8 because the manufacturer figures stronger equals better equals more sales. The free market at work, except the product is your consciousness and the currency is your life. Then there's cross-contamination. A pill press used to make bromazolam pills might also be used to press fentanyl, methamphetamine, or other substances. Residue from previous batches contaminates subsequent runs. Someone thinks they're buying bromazolam and ends up with a pill that also contains trace amounts of fentanyl, enough to trigger an overdose when combined with the benzodiazepine. Labs don't clean equipment between batches because they don't care, don't know better, or don't have the resources. The result is a toxic cocktail of multiple substances in unknown proportions. The visual uniformity of pills creates false confidence. People assume that because 2 pills look identical, they contain identical ingredients in identical amounts. This assumption is lethal. Your brain sees a familiar white bar with Xanax stamped on it and thinks, I know what this is, but you don't. You have absolutely no idea. That pill could be pharmaceutical alprazolam, street bromazolam, fentanyl, or aspirin. The only way to know is through laboratory analysis using techniques like mass spectrometry, which costs hundreds of dollars and takes days. Street users don't have that option. They take pills based on trust. Trust in dealers who themselves don't know what they're selling. Trust in supply chains with zero accountability. Trust in a system designed to maximize profit at the expense of human lives. That trust is misplaced, and the consequences are catastrophic. You might be wondering, why would anyone choose an untested research chemical over a legitimate prescription medication? And the answer is depressingly simple: access and cost. Getting a prescription for Xanax isn't easy anymore. Doctors are increasingly reluctant to prescribe benzodiazepines long-term because of addiction risks and regulatory scrutiny. Insurance companies push back, prescriptions run out. People who genuinely suffer from anxiety disorders get caught in bureaucratic hell, waiting weeks for appointments, getting denied refills, or being told to try yoga and meditation instead of medication. Meanwhile, their anxiety is still screaming, so they turn to alternatives. Bromazolam is cheap, readily available online, and requires 0 prescriptions, insurance forms, or awkward conversations with judgmental doctors. You order it like you're buying shoes. It arrives in discreet packaging, and you self-medicate. For some, it's desperation. For others, it's recreational. They want the Xanax experience without the legal risk. And for dealers, it's profit. They can buy bromazolam powder in bulk, press thousands of fake Xanax bars, and sell them at massive markup to people who have no idea they're not getting real pharmaceuticals. The healthcare accessibility crisis is real and worsening. In the United States, mental health treatment is expensive, underfunded, and stigmatized. A single psychiatry appointment can cost hundreds of dollars without insurance. With insurance, you might wait 3 months for an appointment with a provider who spends 15 minutes with you before writing a prescription for an SSRI and telling you to exercise more. If you specifically need benzodiazepines for acute anxiety or panic disorder, good luck. Doctors are terrified of the DEA, wary of creating dependencies, and pressured by insurance companies to prescribe cheaper alternatives. Even if you get a prescription, it's often for a limited supply, 30 pills to last a month, with no refills until your next appointment in 6 weeks. What happens during that gap? You suffer, or you find alternatives. The cost factor cannot be ignored. Pharmaceutical Xanax, even generic alprazolam, costs money. With insurance, maybe $10 or $20 per month. Without insurance, potentially hundreds. Street Bromazolam, pressed into counterfeit pills, costs a fraction of that. You can buy 100 pills for the price of a month's prescription. For people living paycheck to paycheck, already struggling with the costs of rent and food, the economic calculation is simple. They know street pills are riskier, but they cannot afford the legitimate option, and they cannot function without something to manage their anxiety. There's also the shame factor. Mental health stigma remains pervasive despite public awareness campaigns. People don't want to admit they need psychiatric medication. They don't want their medical records documenting anxiety or panic disorders. They don't want to sit in a therapist's office explaining their symptoms. They don't want to face the judgment, real or perceived, from healthcare providers who might view them as drug-seeking or weak. Buying Bromazolam online eliminates all of that. No appointments, no explaining yourself, no medical records, no judgment. Just a transaction in the privacy of your own home. For recreational users, the calculation is different but equally straightforward. They want the effects of Xanax, the relaxation, the disinhibition, the euphoria when combined with other substances, without the legal risk of possessing a controlled substance. In many jurisdictions, Bromazolam exists in legal grey zones. Possession might not be explicitly illegal, or if it is, enforcement is lax. The risk-reward calculation favours street drugs. And because Bromazolam is marketed as basically the same as Xanax, users convince themselves the risks are equivalent. They're not, but perception shapes behaviour. Dealers love Bromazolam because the profit margins are obscene. A kilogram of powder costs a few $1,000s and can be pressed into hundreds of thousands of pills. Each pill sells for $5 to $20 on the street. The return on investment is staggering. And because Bromazolam is or was legal to import in many countries, the legal risk is lower than trafficking pharmaceutical medications diverted from legitimate supply chains. Dealers aren't altruistic. They're not providing a service to people failed by the healthcare system out of compassion. They're capitalizing on desperation, pain, and systemic failure. But the net effect is the same. People who need anxiety medication get it from illegal sources, take substances of unknown purity and potency, and hope they don't die. That's the reality of drug policy in the 21st century. Let's talk about the supply chain of illegal pharmaceuticals, because it's both fascinating and horrifying. Bromazolam's journey from Chinese lab to your local dealer's backpack is a globalized operation worthy of a business school case study. If business schools taught crime, it starts in chemical factories, mostly in China but also India and other countries with relaxed chemical regulations. These aren't sketchy back-alley operations, they're legitimate businesses supplying research chemicals to laboratories worldwide. Bromazolam powder is manufactured, packaged, and shipped openly because it's technically legal in many jurisdictions. The suppliers even have customer service departments. You can email them questions. It's surreal. Once the powder arrives, usually hidden in shipments labeled as research samples or industrial chemicals, underground labs take over. These range from sophisticated operations with pill presses and mixing equipment to literally someone's garage with a Home Depot scale and a dream. They mix the Bromazolam powder with binders, press it into pills shaped like Xanax bars, add fake pharmaceutical markings, and package them to look legitimate. Then distribution. Darknet markets, encrypted messaging apps, hand-to-hand deals. The pills flow through networks of dealers who often don't even know what they're selling. They were told it's Xanax, and they believe it. The Chinese chemical industry is the backbone of global designer drug production. After economic reforms in the 1980s and 90s, China developed a massive pharmaceutical manufacturing sector. The same facilities that produce legitimate medications for export also produce research chemicals, often operating in legal grey zones. Chinese law regulates specific compounds, but new designer drugs aren't immediately added to controlled substance lists. This creates a window where production and export are legal, even if the substances are illegal in destination countries. Chemical companies advertise openly on Chinese business-to-business platforms. They have professional websites showcasing their catalogs. You can literally browse Bromazolam listings like you're shopping for office supplies, complete with specifications, purity guarantees, and bulk pricing tiers. Shipping is surprisingly straightforward. Bromazolam powder is mailed in small quantities, typically kilograms or less, packaged to avoid detection. Labels describe contents as cosmetic ingredients, industrial samples, or research reagents. Customs inspectors screening millions of packages daily have neither the time nor the resources to chemically test every suspicious shipment. Most packages sail through without inspection. When shipments are intercepted, suppliers simply resend from different addresses using different courier services. It's a numbers game. If 90% of shipments make it through, that's acceptable shrinkage from a business perspective. Once the powder reaches its destination, mid-level operators convert it into finished products. Some operations are remarkably sophisticated, with industrial pill presses capable of producing thousands of tablets per hour, professional packaging equipment, and even quality control testing to ensure consistent dosing. These are criminal enterprises operating as shadow pharmaceutical companies. They invest in equipment, maintain supply chains, and build brand recognition. Yes, street drugs have brands. Certain press styles, colors, and markings become associated with specific manufacturers. Users develop preferences based on perceived quality and consistency. Other operations are depressingly amateurish. Someone buys a manual pill press on Amazon for a few $100s, orders Bromazolam powder and binder supplies from the internet, and starts pressing pills in their apartment. They watch YouTube tutorials, ask questions on Reddit, and learn through trial and error. Quality is non-existent. Doses vary wildly. Contamination is common. But they can produce pills that look legitimate enough to fool buyers, and that's sufficient to enter the market. Distribution occurs across multiple tiers. Large-scale operations sell directly to regional distributors who handle bulk quantities, thousands or tens of thousands of pills. Regional distributors sell to local dealers in smaller quantities, hundreds of pills. Local dealers sell to consumers in even smaller amounts, tens of pills or individual bars. Each tier adds markup until pills that cost pennies to produce sell for $5 to $20 on the street. Everyone profits, and everyone remains insulated from the tier above them through compartmentalization. Street dealers don't know who pressed the pills. Mid-level distributors don't know who synthesized the powder. The supply chain is deliberately fragmented to minimize risk from law enforcement. The Darknet facilitates much of this commerce. Markets operate on the Tor network, accessible only through encrypted browsers, providing anonymity for buyers and sellers. Vendors advertise products with professional listings, customer reviews, and escrow services. Buyers pay with Bitcoin or other cryptocurrencies, further obscuring transactions. Once payment clears, vendors ship products through regular mail systems. Law enforcement struggles to combat this model because arrests barely dent supply. Shut down one market, 3 more emerge. Arrest one vendor, they create new accounts. The Hydra grows new heads faster than they can be severed. And through it all, Bromazolam flows from Chinese factories to American streets, a pharmaceutical river of profit and death that shows no signs of slowing. Here's a nightmare scenario that plays out thousands of times daily. Someone buys what they believe is pharmaceutical Xanax from a dealer or online source. The pill looks perfect, right shape, right markings, right color. They've taken Xanax before. They know what it looks like. So they pop the pill, expecting the familiar relief. Except, this time, something's different. It hits harder, lasts longer, the sedation is deeper, their memory goes completely blank for 12 hours. They wake up confused, having sent bizarre texts, made weird purchases online, or in worst cases, driven somewhere with zero recollection. What they took wasn't Xanax. It was Bromazolam, or some other benzodiazepine analog, pressed into a convincing counterfeit. This is happening everywhere. Emergency rooms see patients weekly who thought they took prescription medication, but were actually overdosing on research chemicals. Counterfeit pills are indistinguishable from real ones without chemical testing. Same size, same stamp, same packaging. Drug dealers are essentially running shadow pharmaceutical companies, and consumers have zero protection. You can't sue them. You can't report them to the FDA. You're just gambling every time you take a pill that didn't come directly from a pharmacy with your name on the bottle. The counterfeiting process has become disturbingly sophisticated. Manufacturers purchase dyes that create authentic-looking pharmaceutical imprints. For Xanax bars, this means the Xanax stamp on one side and the scores that divide the bar into quarters. The dyes are precision machined to create sharp, clear impressions. The pills are pressed using pharmaceutical-grade binders that create the correct texture and hardness. Even the coloring is matched. Some manufacturers use titanium dioxide to achieve the exact white shade of pharmaceutical alprazolam. The final product is visually identical to the real thing. A pharmacist handling hundreds of prescriptions daily would not notice the difference without chemical analysis. Packaging adds another layer of authenticity. Some counterfeiters go so far as to create fake prescription bottles with pharmacy labels, complete with fake patient names, prescription numbers, and dispensing information. Pills arrive in containers that look like they came from CVS or Walgreens. Blister packs mimic pharmaceutical packaging. Foil seals look legitimate. Every detail is calculated to convince buyers they're receiving pharmaceutical products diverted from legitimate supply chains rather than research chemicals pressed in clandestine labs. The human cost is staggering. Users who believe they're taking pharmaceutical Xanax develop a false sense of security. They know what dose they're taking, or so they think. They know how their body responds. They've calibrated their use based on previous experiences with real alprazolam. Then they take a counterfeit pill containing bromazolam or another analog, and everything changes. The dose might be higher, the duration might be longer, the effects might be subtly different in ways they can't quite articulate. But because the pill looks identical to pills that have worked before, they don't attribute problems to the substance. They attribute them to their own misjudgment. I shouldn't have taken 2 bars. Actually, you shouldn't have taken 2 bars of unknown composition containing unregulated research chemicals, but how would you know? The memory blackouts are particularly disturbing. People wake up after taking counterfeit Xanax with entire chunks of time missing. They check their phone and find texts they don't remember sending, sometimes to people they haven't contacted in years. They find confirmation emails for purchases they didn't knowingly make. In extreme cases, they discover they drove cars, went to work, had conversations, all while in a state of anterograde amnesia. To outside observers, they seemed intoxicated but conscious. But no memories were forming. It's like sleepwalking except you're awake, just unable to encode experiences into long-term memory. This creates profound psychological distress. People question their reality, their judgment, their sense of self. What else might they have done that nobody told them about? Legal consequences follow. People commit crimes while blacked out on counterfeit benzodiazepines. Shoplifting, vandalism, assault, driving under the influence. They're arrested, charged, and prosecuted for actions they genuinely cannot remember. Defense attorneys argue diminished capacity, but courts are skeptical of the "I was too high to remember" defense. Juries convict. People serve prison sentences for crimes they have no memory of committing. Their protestations of innocence are met with eye rolls and lectures about personal responsibility. But from their perspective, they went to sleep Wednesday evening and woke up in jail Friday morning with no idea what happened in between. The continuity of consciousness that defines human experience was interrupted, and society holds them accountable anyway. The counterfeit pill crisis is worse than most people realize because it's invisible. When someone overdoses on counterfeit pills, headlines read, "Xanax overdose, not Bromazolam overdose." The public assumes the problem is pharmaceutical medications, not research chemicals. Policy responses target legitimate prescriptions, making it harder for people with genuine medical needs to access care. Meanwhile, the street supply remains contaminated, and counterfeit pills continue flooding the market. It's a crisis hiding in plain sight, disguised as something familiar, killing people who think they're being careful. The Darknet, that encrypted, anonymous corner of the internet accessible only through special browsers, has become the Amazon of illegal drugs. It operates like any e-commerce platform. Vendor listings, customer reviews, escrow services, even dispute resolution. Except the products are substances that could kill you. Bromazolam flourished here because it occupied a sweet spot. Technically legal in many places when purchased as a research chemical, but functionally identical to controlled substances. Vendors openly advertised it, shipped it internationally, and built reputations based on product quality and delivery speed. Buyers could compare prices, read reviews, great product, blacked out for 8 hours, 5 stars, and order with cryptocurrency for anonymity. Law enforcement struggles to shut these markets down because they're decentralized, encrypted, and operate across international borders. Shut down one market, 3 more pop up. Arrest one vendor, they create a new account. It's Hydra-level persistence, but the Darknet markets, ironically, sometimes offered better quality control than street dealers. Vendors had reputations to protect, so they tested products, disclosed doses, and warned about risks. Not always, but often. Street dealers? They have no reviews, no accountability, and zero incentive to tell you the truth. The architecture of Darknet markets is designed for resilience. They operate on the Tor network, which routes internet traffic through multiple encrypted layers, making it nearly impossible to trace users or identify server locations. Market operators maintain mirror sites on multiple servers across different countries. If law enforcement takes down one server, users simply access the market through alternate links. The entire system is built to be Hydra-like. Chop off one head, 2 more grow back. Vendor culture on these markets is surprisingly professional. Top vendors treat drug dealing like a legitimate business. They maintain consistent quality, ship orders promptly, and respond to customer service inquiries within hours. They offer stealth shipping, products disguised as legitimate goods in professional packaging designed to pass through customs. Some vendors include thank you notes and even candy as extras, like Etsy sellers trying to build brand loyalty, except instead of handmade candles, they're selling benzodiazepines that could put you in a coma. The review system creates perverse incentives. Vendors with good reviews attract more customers and command premium prices. This encourages quality control. Vendors who sell contaminated or misdosed products get negative reviews and lose business. In some ways, the Darknet's reputation system creates better accountability than street-level drug dealing, where there are no reviews and no recourse if you're sold garbage. But it also creates a veneer of safety. 5-star reviews and professional customer service make buying illegal drugs feel mundane, routine, safe. It's not. No. You're still ordering unregulated chemicals from anonymous strangers, but the UX design makes it feel like ordering from Amazon. Cryptocurrency adds another layer of anonymity. Bitcoin was the original Darknet currency, but its blockchain is traceable with sufficient resources. Newer cryptocurrencies like Monero offer enhanced privacy features that make transactions nearly untraceable. Buyers purchase cryptocurrency through exchanges, tumble it through mixing services to obscure its origin, then use it to pay vendors. The entire transaction chain is designed to prevent law enforcement from following the money trail. Escrow systems protect both buyers and sellers. When an order is placed, payment is held by the market in escrow. The buyer receives the product, tests it, and confirms receipt. Only then is payment released to the vendor. If the product doesn't arrive or is unsatisfactory, the buyer can dispute the transaction, and market administrators mediate. It's like PayPal buyer protection, except for drugs. This system reduces scams and builds trust in markets that otherwise operate on pure anonymity. Law enforcement has achieved notable successes. The FBI shut down Silk Road in 2013, arresting its creator and seizing millions in assets. Alphabay and Hansa were taken down in coordinated international operations in 2017, but these victories are Pyrrhic. Each time a major market falls, users migrate to newer platforms. The overall drug trade barely slows. Vendors simply set up shop elsewhere, and the technology continues evolving. Decentralized markets with no central operators are emerging, making takedowns even harder. The Darknet's role in Bromazolam distribution is significant but often overstated. Most drug transactions still occur in physical space through traditional dealer networks. But Darknet markets serve as a wholesale source feeding those street-level operations. Mid-level dealers order bulk quantities online, then distribute locally. The Darknet provides the supply. The streets provide the distribution. Together, they form a resilient, adaptive network that has proven remarkably resistant to enforcement efforts. Bromazolam flows through this network like water finding cracks in concrete, reaching users who want anxiety relief and don't care whether their pills came from Pfizer or a chemist in Shanghai with questionable ethics. Benzodiazepines are sneaky addictive. They don't announce themselves like cocaine or heroin. There's no intense rush, no euphoric high, just relief, just calm, just finally feeling normal. And that's exactly why they're so dangerous. Bromazolam works the same way. You take it for anxiety, and it works beautifully. Panic attacks disappear. Social situations become tolerable. Sleep finally comes, so you take it again and again, and your brain, clever little traitor that it is, starts adapting. GABA receptors downregulate, meaning you need more bromazolam to achieve the same effect. Tolerance builds fast, sometimes within weeks. What started as one pill becomes 2, then 3, then daily use, then multiple times daily. And here's the trap. You don't realize you're addicted until you try to stop. Because benzodiazepine withdrawal is hell, not metaphorical hell, actual, physical, potentially life-threatening hell. Your brain, now dependent on external GABA enhancement, freaks out when you stop. Anxiety rebounds worse than before. You shake uncontrollably. You can't sleep. You have seizures. In severe cases, withdrawal can literally kill you. Alcohol and benzodiazepines are the only two drug classes where withdrawal itself can be fatal. So people keep taking bromazolam not because they want to, but because stopping is unbearable. The neurological mechanism of benzodiazepine addiction is insidious. Your brain is constantly seeking homeostasis, a balanced state where everything functions optimally. When you introduce bromazolam regularly, your brain recognizes that GABA-A receptors are being overstimulated. In response, it downregulates these receptors, reducing their numbers or making them less sensitive. It's the brain's attempt to counteract the drug's effects and return to baseline. Except baseline no longer exists without the drug. You've shifted your neurological equilibrium. What was once a normal, drug-free state now registers as insufficient. Your natural GABA production, which was adequate before, is now insufficient to activate the reduced number of receptors. The result? You need bromazolam just to feel normal, not to feel good, to feel baseline human functionality. Tolerance escalates quickly with benzodiazepines. Within 2 weeks of daily use, you might notice the initial dose doesn't work as well. Within a month, you might be taking double or triple your starting amount. Within 3 months, you're chasing a feeling you can't quite recapture, taking doses that would have knocked you unconscious initially but now barely keep your anxiety at bay. This is called tolerance escalation, and it's one of the hallmarks of physical dependence. Your body has adjusted to the presence of the drug so thoroughly that higher doses are required to achieve any effect at all. The psychological component is equally powerful. Bromazolam provides immediate relief from psychological suffering. That relief becomes associated with the act of taking the pill. Pavlovian conditioning kicks in. Your brain learns stress equals pill equals relief. This pattern becomes deeply ingrained. Every time you face a difficult situation, your first thought is the pill. Job interview? Pill. First date? Pill. Difficult conversation? Pill. The drug becomes your coping mechanism, your emotional crutch, your solution to all discomfort. And because it works, it genuinely does reduce anxiety. The behavior is powerfully reinforced. Why would you stop doing something that makes you feel better? The social isolation compounds the problem. Many people using street bromazolam hide their use from friends and family. They take pills secretly, maintain a facade of normalcy, and struggle alone. This isolation prevents intervention. Nobody notices the escalating use until something dramatic happens. An overdose, a blackout incident, a medical emergency. By that point, physical dependence is severe and withdrawal is dangerous. The person wants to stop but literally cannot without medical supervision. Financial consequences mount. As tolerance increases, so does consumption. What started as spending $50 a month becomes $200, then $500. People drain savings accounts, max out credit cards, or engage in illegal activities to fund their habit. The financial pressure adds stress, which increases anxiety, which drives more drug use. It's a vicious cycle where the solution to drug-related problems is more drugs. Relationships deteriorate. Memory blackouts lead to missed commitments, forgotten conversations, and inexplicable behavior. Partners, friends, and family members lose trust. You promised you'd stop. You said that was the last time. But addiction isn't about willpower or promises. It's about neurological dependence and the terror of withdrawal. People continue using not because they're weak or morally deficient, but because their brain has been chemically remodeled to require the drug for basic functioning. The realization of addiction often comes suddenly. Someone runs out of pills and decides to take a few days off. Within 12 hours, they feel anxious. Within 24 hours, they're shaking, sweating, unable to sleep. Within 48 hours, panic sets in. By 72 hours, they're back at the dealer, convinced they'll quit next week. Next week becomes next month, becomes never. The window where quitting felt possible has closed. Physical dependence has transformed a choice into a necessity. You're not taking Bromazolam to feel good anymore. You're taking it to avoid feeling like you're dying. That's addiction. Let's paint a picture of benzodiazepine withdrawal, because it's genuinely one of the worst experiences human biology can produce. Imagine taking your baseline anxiety and multiplying it by 10. Now add uncontrollable shaking, sweating, nausea, and insomnia so severe you don't sleep for days. Your heart races, your thoughts spiral. Reality feels wrong, distorted, terrifying. Sounds are too loud, lights are too bright, your skin crawls. This is acute withdrawal, and it can last weeks. But wait, there's more. After the acute phase comes post-acute withdrawal syndrome or pause, which can linger for months. During pause, you randomly experience panic attacks, depression, cognitive impairment, and waves of physical discomfort that make you feel like you're constantly on the verge of losing your mind. The worst part? Bromazolam, being unregulated, often comes in unknown doses and combinations. People accidentally take massive amounts without realizing it, develop severe physical dependence, and then face withdrawal so dangerous it requires medical supervision. But they can't seek medical help because admitting they were taking illegal drugs might result in legal consequences or judgment, so they suffer alone, sometimes attempting rapid tapers that trigger seizures. Medical professionals recommend extremely slow tapers for benzodiazepine withdrawal, often months-long processes reducing doses by tiny increments. With street Bromazolam, that's nearly impossible. Doses are inconsistent. Purity varies. You can't taper what you can't measure. The timeline of benzodiazepine withdrawal is brutal. For short-acting benzos like alprazolam, symptoms begin within 6 to 12 hours of the last dose. For longer-acting compounds like Bromazolam, it might take 24 to 48 hours. The delay creates false hope. People think they're fine, that their dependence wasn't that severe, and then withdrawal hits like a freight train. The first symptoms are rebound anxiety and insomnia, the original symptoms you were treating, but amplified. Your anxiety isn't just back. It's worse than it ever was before you started taking the drug. Panic attacks that previously occurred weekly now happen hourly. Sleep becomes impossible. You lie in bed, mind racing, body tense, until sunrise brings no relief. Physical symptoms escalate rapidly. Tremors begin in the hands and spread throughout the body. Not subtle shaking, visible, uncontrollable tremors that make it difficult to hold objects, type on a keyboard, or eat without spilling food. Sweating drenches your clothes within minutes of changing. Nausea makes eating impossible. Vomiting provides no relief because your stomach is empty and you're dry heaving. Muscle aches make every movement painful. Your heart races at rest, pounding in your chest like you just finished a sprint. Blood pressure spikes dangerously high. Sensory hypersensitivity turns the world hostile. Ordinary sounds, conversations, traffic, music become painfully loud and intrusive. Bright lights feel like knives stabbing your eyes. Textures feel wrong against your skin. Even soft clothing becomes irritating. Smells trigger nausea. Your nervous system, accustomed to benzodiazepine-enhanced inhibition, is now firing without restraint. Every stimulus gets amplified, unfiltered, overwhelming. The psychological symptoms are equally terrifying. Depersonalization and derealization make reality feel unreal. You look at your hands, and they don't feel like yours. You look in the mirror, and the face staring back seems unfamiliar. The world appears flat, distant, dreamlike. This isn't psychosis. You know rationally that reality is real, but the feeling persists, creating profound existential dread. Intrusive thoughts flood your mind. Dark, disturbing images and ideas you'd never normally entertain become obsessive. You're not suicidal, but thoughts of death intrude constantly. Your brain, deprived of its chemical stabilizer, spirals through worst-case scenarios without reprieve. Seizures are the deadly wild card. Benzodiazepine withdrawal seizures can occur suddenly without warning, even in people with no history of epilepsy. One moment you're conscious, the next you're convulsing on the floor, potentially hitting your head, biting your tongue, aspirating vomit. These aren't mild seizures. They're grand mal seizures that can cause brain damage or death. The risk is highest in the first week of withdrawal but can persist for weeks. This is why medical supervision is mandatory. Attempting to quit benzodiazepines cold turkey is Russian roulette with neurological bullets. Post-acute withdrawal syndrome extends the suffering for months after acute symptoms resolve. You're no longer shaking or vomiting, but you're not right. Anxiety and depression persist at lower but still significant levels. Cognitive function remains impaired. Difficulty concentrating, memory problems, slowed thinking, sleep disturbances continue. You fall asleep easily but wake repeatedly throughout the night, never achieving restorative rest. Waves of physical discomfort wash over you randomly. Muscle tension, chest tightness, dizziness. These symptoms come and go unpredictably, creating constant uncertainty. You have good days where you think you're recovering, followed by bad days where you feel like you've regressed completely. The cruelty of benzodiazepine withdrawal is that the treatment for the symptoms is the drug itself. You're suffering because your brain lacks the drug, and reintroducing the drug would provide instant relief. This makes relapse almost inevitable without support. The temptation to take just one pill to make the agony stop is overwhelming. And when people relapse, they often binge, taking massive doses to compensate for the suffering, which only deepens physical dependence and makes the next withdrawal attempt even worse. It's a neurological trap with walls that grow higher every time you try to escape. Bromazolam overdose doesn't look like movies portray drug overdoses. There's no dramatic collapse or immediate death. It's slower, quieter, and insidious. Someone takes too much, either accidentally or intentionally, and the central nervous system depression intensifies. First comes extreme sedation. They can barely keep their eyes open, can't form coherent sentences, can't walk without stumbling. Their breathing slows, shallow breaths, longer pauses between them. Their blood oxygen levels drop. If they're alone, nobody notices. If they're with people, those people might just think they're really fucked up and not realize it's medical emergency territory. Here's the terrifying part. Benzodiazepine overdose alone is rarely fatal. The therapeutic index, the gap between effective dose and lethal dose, is actually pretty wide. But nobody takes bromazolam alone. They mix it with alcohol, with opioids, with other drugs. And that's when respiratory depression becomes respiratory arrest. Your brain literally forgets to tell your lungs to breathe. Naloxone, the opioid overdose reversal drug, doesn't work on benzodiazepines. There's no quick fix. Treatment is supportive care, breathing tube, ventilator, IV fluids, wait it out. Sometimes people wake up days later with no memory of nearly dying. Sometimes they don't wake up at all. And because it's street bromazolam with unknown potency, even experienced users can miscalculate and end up in intensive care. The physiological cascade of benzodiazepine overdose follows a predictable but variable timeline. Initial overdose symptoms appear within 1 to 2 hours of ingestion. Extreme drowsiness progresses to stupor. The person is conscious but barely responsive. Speech becomes slurred and incomprehensible. Motor coordination fails completely. Attempting to walk results in falling. Reflexes slow dramatically. Shine a light in their eyes, and pupil response is sluggish. Touch their hand, and they barely register sensation. The person exists in a twilight state between consciousness and unconsciousness, aware of their surroundings in a vague, dreamlike way but incapable of purposeful action. Respiratory depression is the primary danger. Normal breathing rates are 12 to 20 breaths per minute. In benzodiazepine overdose, this drops to 6 to 8 breaths per minute, then potentially lower. Each breath becomes shallower, moving less air. The body's oxygen saturation drops from the normal 98 to 100% down to 90%, then 85, then lower. Cyanosis appears, lips and fingernails turning blue from oxygen deprivation. The brain, starved of oxygen, begins suffering damage. Neurons die. Cognitive functions impair permanently if oxygen deprivation continues too long, and the person, heavily sedated, is unaware this is happening. They're not gasping for air or struggling, they're just slowly suffocating while unconscious. The combination problem cannot be overstated. Benzodiazepines and opioids together create synergistic effects. The total effect is greater than the sum of the parts. Someone takes bromazolam for anxiety, then uses heroin recreationally, and the combined respiratory depression is catastrophic. The benzodiazepine suppresses breathing. The opioid suppresses breathing. Together, they shut down respiration almost completely. This is why so many overdose deaths involve both drug classes. Toxicology reports show benzodiazepines in the system, alongside fentanyl or heroin. Neither drug alone might have been lethal at those doses, but together they're deadly. Alcohol is equally dangerous. Ethanol is also a central nervous system depressant acting on GABA receptors. Adding alcohol to bromazolam amplifies sedation and respiratory depression. People take a pill, go to a bar, have a few drinks, and never wake up. It's so common it's become a dark joke among emergency medicine physicians. Benzos and booze, one-way ticket to the ICU. But people continue mixing them because both are socially acceptable, readily available, and the dangers aren't immediately apparent. You don't feel yourself dying. You just feel very, very relaxed until you stop breathing. Aspiration is another deadly complication. Someone overdosing on benzodiazepines often vomits while unconscious. Normally, protective reflexes prevent vomit from entering the lungs. But heavy sedation suppresses these reflexes. Vomit gets aspirated into the lungs, causing chemical pneumonitis and blocking airways. The person drowns on their own stomach contents without ever regaining consciousness. This is why the recovery position, lying on the side, is critical for anyone heavily intoxicated. It allows fluids to drain from the mouth rather than pooling in the throat. Flumazanil exists as a benzodiazepine antagonist, a medication that reverses benzodiazepine effects by blocking their receptor binding. It's the theoretical antidote. But it's rarely used outside hospitals because it has significant risks. In people who are physically dependent on benzodiazepines, flumazanil can trigger acute withdrawal and seizures. The treatment is potentially worse than the overdose. Additionally, flumazanil's effects are shorter-lived than many benzodiazepines, so patients can slip back into overdose after the antidote wears off. Medical protocols favor supportive care, maintaining breathing and circulation until the drug metabolizes naturally. The aftermath of surviving overdose is traumatic. People wake up intubated in ICUs, restrained to beds, with no memory of how they got there. Medical bills pile up, emergency transport, ICU stays, monitoring tests. Insurance may not cover treatment for self-inflicted drug overdoses. Families are traumatized, angry, relieved, confused. The person who overdosed faces judgment, shame, and fear. And often within weeks or months, they're using again because the underlying issues, addiction, mental health problems, pain, remain unaddressed. Surviving overdose doesn't guarantee recovery. Without intervention, it's often just a preview of the fatal one coming next. Let me introduce you to the concept of polysubstance use, which is a fancy way of saying taking multiple drugs at once and hoping for the best. Bromazolam doesn't kill most people by itself. It kills them when combined with other central nervous system depressants. Alcohol is the most common culprit. Someone takes bromazolam for anxiety, then drinks because they're at a party or stressed or bored, and both substances amplify each other's effects exponentially. 1 + 1 doesn't equal 2, it equals 5. Your breathing slows, your judgment disappears, and suddenly you're face down in a situation you didn't plan for. Opioids are even worse. The overdose crisis isn't just fentanyl, it's fentanyl mixed with benzodiazepines. Drug dealers cut heroin with bromazolam to intensify the high. Users unknowingly take both. The combined respiratory depression is catastrophic. Even therapeutic doses of each can become lethal together. Then there are less obvious interactions. Muscle relaxants, sleep medications, antihistamines, even some antidepressants can potentiate bromazolam's effects. Your brain's respiratory center just gives up because too many chemicals are telling it to chill out. The pharmacological basis for dangerous drug interactions lies in shared mechanisms of action. Multiple substances affecting the same physiological systems create additive or synergistic effects. Bromazolam enhances GABA-A receptor activity, reducing neuronal excitability throughout the central nervous system. Alcohol does the same thing through slightly different mechanisms. It enhances GABA-A activity and inhibits glutamate receptors. Opioids work on different receptors but ultimately suppress brainstem respiratory centers. When you combine these substances, you're hitting the brain's slow-down button from multiple angles simultaneously. The result is profound depression of all central nervous system functions, particularly the automatic processes that keep you alive. The dose-response relationship becomes unpredictable with polysubstance use. A dose of bromazolam that's safe on its own becomes dangerous with alcohol. A dose of opioids that's manageable alone becomes lethal with benzodiazepines. And because street drugs have inconsistent potency, users can't calculate safe combinations. They're guessing, and guesses kill people. Someone thinks they're taking their usual dose of both substances, not realizing this batch of pills is twice as strong as the last batch. The familiar combination suddenly becomes deadly. Prescription medications create hidden dangers. Many people taking bromazolam recreationally are also prescribed legitimate medications for other conditions. Gabapentin, a nerve pain medication, potentiates benzodiazepine effects. Muscle relaxants like cyclobenzaprine add sedation. Sleep medications like zolpidem or ezopicolone compound, respiratory depression. Antihistamines like diphenhydramine found in over-the-counter sleep aids and allergy medications have sedating effects. Even certain antidepressants, particularly tricyclics and MAO inhibitors, interact dangerously with benzodiazepines. People don't think of these as drugs in the recreational sense, so they don't consider interactions. They take their prescribed medications as directed, then add bromazolam on top, and create a toxic cocktail without realizing it. The timing of drug consumption matters enormously. Taking substances hours apart reduces but doesn't eliminate interaction risks. Bromazolam's long half-life means it's still active in your system for 12 to 24 hours after ingestion. Taking opioids 12 hours after bromazolam means both drugs are present simultaneously, even if you think the first dose has worn off. The subjective feeling that a drug has stopped working doesn't mean it's gone from your body. Metabolites remain active. Blood levels decline slowly. Overlapping drug windows create dangerous periods where multiple substances interact. Tolerance complicates the picture further. Someone who uses bromazolam regularly develops tolerance to benzodiazepines, but not necessarily to opioids or alcohol. They take what feels like a normal dose of bromazolam, higher than what would affect a naive user, then add alcohol at typical recreational doses. Their benzodiazepine tolerance makes them feel functional, so they drink more. But their alcohol tolerance hasn't increased proportionally. The combination overwhelms their system. Similarly, opioid-tolerant users might take massive heroin doses they've adapted to, then add bromazolam and tip into fatal overdose territory. Cross-tolerance is incomplete and unpredictable. The social context of polysubstance use drives dangerous combinations. People take bromazolam for anxiety, then social situations involve alcohol. Party culture combines multiple substances: stimulants to stay awake, depressants to take the edge off, alcohol because it's everywhere. Each substance alone might be manageable. Together, they create a chemical storm inside the central nervous system. And because intoxication impairs judgment, people continue adding substances even as warning signs appear. Someone slurring their words and stumbling decides, another drink sounds great. A person nodding off thinks one more pill will perk them up. The drugs themselves prevent recognition of danger. Emergency responders face nightmares with polysubstance overdoses. Naloxone reverses opioid effects but not benzodiazepines. Flumazenil reverses benzodiazepines but has serious risks. There's no universal antidote for mixed overdoses. Treatment is supportive. Maintain breathing, support circulation, wait for metabolism. Sometimes ventilators keep people alive for days while drug combinations slowly clear their systems. Sometimes medical interventions come too late. Brain damage from oxygen deprivation is permanent. And throughout this, medical teams often have no idea what substances were actually consumed because street drugs are unidentified mysteries. They treat symptoms blindly, hoping their interventions match the toxicology accidentally created by underground chemists and careless users. One of bromazolam's most disturbing side effects is anterograde amnesia, the complete inability to form new memories while under its influence. You're conscious, walking, talking, making decisions, but your brain isn't recording any of it. It's like someone unplugged your save function. Hours disappear. You wake up the next day with texts you don't remember sending, purchases you don't remember making, conversations you apparently had but can't recall. In some cases, people commit crimes, shoplifting, vandalism, even assault, with zero memory afterward. This isn't blackout drunk where things are hazy. This is complete erasure. Neurologically, bromazolam interferes with the hippocampus's ability to transfer short-term memories into long-term storage. The memories literally never form. They're gone forever. You can't retrieve them through hypnosis or therapy. They simply don't exist. This creates horrifying legal situations. People are arrested for actions they genuinely don't remember. They pass lie detector tests because they honestly believe they didn't do it. Their brain has no record of the event. The hippocampus is the brain structure responsible for memory consolidation. When you experience something, a conversation, an event, a decision, that information enters working memory first. It's held temporarily in neural circuits while your brain decides whether it's worth keeping. Important information gets transferred to the hippocampus for consolidation into long-term memory. This process requires specific neurological conditions. Neurons must be sufficiently active. Certain neurotransmitters must be present. The consolidation process is delicate and easily disrupted. Benzodiazepines disrupt memory consolidation by enhancing GABAergic inhibition throughout the brain, including the hippocampus. Excessive inhibition prevents the neuronal activity necessary for memory formation. Information enters working memory but never makes it to long-term storage. The transfer process fails. It's like trying to save a document on a computer where the save button is broken. You can work on the document, edit it, see it on screen, but nothing saves to the hard drive. Close the program and everything is gone forever. The phenomenon of benzodiazepine-induced amnesia is dose-dependent. Low doses might impair memory subtly, difficulty recalling details, hazy recollections. Moderate doses create significant memory gaps, large chunks of time lost. High doses produce complete blackouts, total absence of memory formation for hours. With street bromazolam, users don't know what dose they're taking. A pill might contain 2 milligrams or 10 milligrams. The amnesia effect is correspondingly unpredictable. Sometimes they remember most of the experience. Sometimes they remember nothing from the moment the drug took effect until they woke up the next day. The subjective experience during amnesia is particularly unsettling. During the blackout period, the person doesn't feel like they're impaired. They think they're forming memories normally. They engage in conversations, make plans, promise commitments, all with the conviction that they'll remember later. But they won't. Other people interacting with them might not realize anything is wrong. The person seems intoxicated but not obviously amnestic. They respond to questions, react to situations, maintain some coherence. Only afterward, when they have zero recollection of events that others witnessed, does the full scope of amnesia become apparent. The legal ramifications are profound and troubling. Imagine being arrested for assault. Witnesses testify you punched someone. Video footage shows you throwing punches. But you have absolutely no memory of the incident. You don't remember being at that location. You don't remember the argument. You don't remember violence. Your last memory is taking what you thought was Xanax before going out. From your subjective perspective, you went to sleep at 11 p.m. and woke up in jail. Everything in between is a void. Your attorney argues diminished capacity. The prosecution argues voluntary intoxication isn't a defense. The jury convicts based on evidence you cannot refute because you genuinely don't remember doing it. These cases raise philosophical questions about culpability and consciousness. Is a person responsible for actions taken while their brain was incapable of forming memories? They were conscious in some sense. Their eyes were open. They responded to stimuli. They made choices. But was that them making choices, or was it some autopilot version stripped of the memory formation that creates continuity of self? Legal systems generally hold people responsible regardless, treating drug-induced amnesia as a foreseeable consequence of voluntary intoxication. But this feels incomplete. The person being punished has no experiential connection to the crime. They're being held accountable for actions taken by someone who looked like them, but whose experiences vanished into neurological oblivion. The social consequences extend beyond legal troubles. Relationships fracture when amnesia creates mistrust. You promised you'd stop taking those pills. I did stop, I swear. But during a blackout, the person bought more pills, took them, and has no memory of breaking their promise. Partners and friends stop believing anything said during intoxication. Trust erodes completely. The amnestic person insists they're telling the truth. They genuinely don't remember, but from the outside, it looks like pathological lying. Financial disasters occur frequently. People in benzodiazepine blackouts shop online compulsively, making purchases they don't remember and can't afford. They wake up to confirmation emails for products they never wanted, charged to maxed-out credit cards. They gamble online, gamble at casinos, make impulsive financial decisions with lasting consequences. One blackout episode can create debt that takes years to resolve. And through it all, the person faces judgment. How could you be so irresponsible for actions they literally cannot recall taking? The only protection against benzodiazepine amnesia is avoiding high doses and avoiding combinations with alcohol, which dramatically enhances amnesia. But with street bromazolam, dose control is impossible. Every pill is a gamble. You might take your usual dose and remember everything, or you might accidentally take 5 times that amount and wake up in a police station with no idea how you got there. The unpredictability transforms every use into a game of neurological Russian roulette, where the bullet is the complete erasure of your own experience. Here's the bureaucratic nightmare keeping bromazolam in circulation. Drug laws can't keep up with chemistry. Traditional drug scheduling systems work like this. A specific chemical compound is identified, studied, deemed dangerous, and added to controlled substance lists. But this process takes years. Legislation moves slowly. Meanwhile, chemists synthesize new compounds faster than regulators can ban them. Bromazolam existed in legal limbo for years. In many countries, it still does. It's not explicitly illegal, which means technically it can be manufactured, sold, and possessed, unless authorities invoke analog drug laws, which require proving the substance is substantially similar to a controlled substance and intended for human consumption. But vendors sidestep this with not-for-human consumption disclaimers. They sell it as research chemicals for laboratory use only, wink wink. Even when countries do ban it, enforcement is complicated. How do you prosecute someone for possessing a substance that was legal when they bought it? International shipments are hard to intercept. Chemical names can be tweaked slightly to create technically new compounds. It's a game of bureaucratic whack-a-mole where the rules change slower than the moles move. The Federal Analog Act in the United States, enacted in 1986, was supposed to solve this problem. It allows prosecutors to treat chemical analogues of controlled substances as controlled substances themselves if they meet two criteria: substantially similar chemical structure and intended for human consumption. Sounds perfect, right? Except both criteria are maddeningly vague and difficult to prove in court. What constitutes substantially similar structure? Minor molecular changes can dramatically alter pharmacological effects. A compound might look similar structurally but act completely differently in the body. Defense attorneys exploit this ambiguity successfully. The intended for human consumption requirement creates another loophole. Chemical suppliers label products as research chemicals, not for human consumption. They sell to buyers who claim to be researchers. The transaction appears legitimate. Proving the seller knew the buyer intended to consume the substance requires evidence, communications explicitly discussing human use, marketing materials targeting recreational users, testimonials about effects. Without that evidence, prosecution falters. Vendors maintain plausible deniability. They're just chemical suppliers serving the legitimate research community. International law complicates matters further. Drug scheduling isn't universal. Substances banned in the United States might be legal in China, India, or Eastern Europe. Chemical manufacturers in countries where bromazolam is legal can export it openly to countries where it exists in legal grey zones. Customs agents at borders face millions of packages daily. Testing every shipment for every possible research chemical is impossible. Most packages slip through unchecked. When shipments are intercepted, penalties are minimal. Seizure and destruction of product, maybe a warning letter. The financial loss is trivial compared to overall profits. Some countries have implemented blanket scheduling for entire classes of compounds. New Zealand pioneered this approach with the Psychoactive Substances Act, which bans all psychoactive substances by default unless explicitly approved as safe. The United Kingdom enacted similar legislation with blanket bans on entire chemical families. These laws close loopholes proactively, but they create new problems. Legitimate pharmaceutical research becomes complicated. Companies must navigate regulations to study new compounds. Innovations are stifled, and even blanket bans have limits. Chemists can create substances structurally different enough to escape class definitions while retaining desired psychoactive effects. The regulation timeline is predictable. A new designer drug emerges, gains popularity, causes overdoses and deaths. Media reports generate public outcry. Legislators propose scheduling. Bureaucratic processes inch forward, and eventually, maybe, the substance gets banned. This cycle takes years. During that window, the drug floods markets and embeds itself in drug culture. By the time it's finally scheduled, users have moved to the next analog and the cycle repeats. Bromazolam followed this exact pattern. It was synthesized decades ago, rediscovered by underground chemists in the 2010s, sold openly as a legal research chemical, gained popularity as a Xanax substitute, caused increasing numbers of overdoses, and is now being scheduled in various jurisdictions. But it took years to reach this point. Thousands of people became addicted or died, while regulators argued about molecular structures and legislative language. Enforcement faces resource constraints, even when laws exist. Police and prosecutors prioritize trafficking organizations over individual users. Someone caught with a few pills of unscheduled bromazolam probably won't face charges. Meanwhile, the manufacturers and distributors operate internationally from jurisdictions with minimal cooperation with US law enforcement. Chinese chemical suppliers ignore cease and desist letters from American authorities. What leverage does the DEA have against a company operating legally under Chinese law? Diplomatic pressure yields limited results. The United States can't dictate drug policy to sovereign nations, especially major powers like China. The ultimate solution isn't better drug laws, it's addressing why people want these substances in the first place. Demand drives supply. As long as anxiety disorders go undertreated, as long as healthcare remains inaccessible, as long as people seek relief from psychological suffering, they'll find substances to fill that need. Ban bromazolam and users switch to the next research chemical. Ban that one and another emerges. The problem isn't individual substances, it's systemic failures in mental health care, addiction treatment, and drug policy. But addressing root causes is politically difficult and expensive, so we keep playing whack-a-mole with designer drugs, winning occasional battles while losing the war. Let's be clear, the safest approach is don't take unregulated research chemicals purchased from strangers on the internet. But humans have been ignoring safety advice since we discovered fire could burn us. So here's harm reduction for those determined to play pharmacological roulette. First, test your substances. Reagent test kits exist for benzodiazepines. They won't tell you exact doses, but they can confirm whether what you have is actually a benzo and not something worse. Fentanyl test strips are essential because dealers sometimes cut anything with fentanyl. Second, start with tiny doses. We're talking crumbs. A quarter of a pill, even less. Wait 2 hours. See what happens. Unknown potency means your 2 mg pill might be 10 mg. Third, never mix. No alcohol, no opioids, no other depressants. Take one substance at a time like a responsible, reckless person. Fourth, have a sober sitter. Someone who isn't taking anything and can call emergency services if you stop breathing. Fifth, tell someone what you took. Pride kills people. I don't want to get in trouble is a lousy epitaph. Sixth, keep naloxone nearby. It won't reverse benzo overdoses, but if your bromazolam was cut with fentanyl, it could save your life. Testing is the foundation of harm reduction. Reagent test kits use chemical reactions that produce color changes indicating the presence of specific drug classes. For benzodiazepines, Morris reagent turns purple in the presence of benzos. The test takes minutes and costs a few dollars per use. It won't tell you whether your pill contains bromazolam specifically versus another benzodiazepine analog, and it won't tell you how much is in there, but it will tell you whether benzodiazepines are present at all. This rules out pills containing only filler or entirely different drugs. Fentanyl test strips are even more critical. These immunoassay strips detect the presence of fentanyl and many fentanyl analogues at very low concentrations. You dissolve a tiny sample of your pill in water, dip the test strip, and wait for results. 1 line means fentanyl is present, don't take that pill. 2 lines mean no fentanyl detected, the pill might be safer, though not safe. These strips have saved countless lives by detecting contamination before consumption. They're cheap, widely available through harm reduction organizations, and remarkably effective. The only downside is they require pre-planning and self-control. Testing your drugs before using them when you're desperately seeking anxiety. Relief requires willpower many people lack. The start low, go slow approach is pharmacological common sense. With unknown potency, every dose is an experiment. Starting with a quarter pill, or even less, means if the pill is drastically overdosed, you've taken a survivable amount. Wait 2 full hours before redosing. Benzodiazepines take time to reach peak blood levels. The effects at 30 minutes might not represent full effects at 90 minutes. Impatient users redose too quickly, stacking doses, and end up taking far more than intended. Patience is literally life-saving. The no-mixing rule seems obvious, but is frequently violated. People take Bromazolam for anxiety, then encounter social situations involving alcohol. Just a couple drinks seems harmless. But those couple drinks, combined with an unknown dose of a long-acting benzodiazepine, can trigger respiratory depression. The rule must be absolute. If you take Bromazolam, no other depressants for at least 24 hours, no alcohol, no opioids, no muscle relaxants, no sleep medications. People who cannot follow this rule should not take Bromazolam at all, though realistically many will anyway. Sober sitters provide accountability and emergency intervention. Ideally, this is someone who cares about you, knows what substance you took and approximately how much, and is prepared to call emergency services if anything goes wrong. They watch for warning signs: slurred speech progressing to unconsciousness, breathing slowing below 8 breaths per minute, blue lips or fingernails, inability to wake the person. Having a sober sitter eliminates the scenario where someone overdoses alone and dies because nobody found them in time. Informing others what you took seems counterintuitive. Admitting drug use risks judgment. But in overdose scenarios, this information is critical. Emergency responders treat overdoses differently depending on the substances involved. I think they took benzodiazepines helps paramedics make better decisions than I don't know what they took. Good Samaritan laws in many jurisdictions protect people who call for help during overdoses from drug possession charges. The legal risk is minimal. The potential life saved is yours or someone you care about. Naloxone availability is cheap insurance against fentanyl contamination. Naloxone kits cost $20 to $40 and are available without prescription in most states. The medication reverses opioid overdoses within minutes. If your Bromazolam is contaminated with fentanyl, which happens more often than you'd think, naloxone could be the difference between life and death. It won't reverse benzodiazepine effects, but mixed overdoses are common and the opioid component often kills first. Other harm reduction strategies include using with others rather than alone. At least then someone might notice if you stop breathing. Avoiding combining substances, even if they're not all depressants. Stimulants plus depressants strain your cardiovascular system. Keeping your tolerance low by avoiding daily use. The less dependent you are, the safer occasional use becomes. And having an exit plan, knowing how you'll taper off and under what conditions you'll seek help. None of these strategies make Bromazolam safe. They make it less catastrophically dangerous. The difference between unsafe and slightly less unsafe might seem trivial, but when we're talking about the difference between waking up tomorrow and not waking up at all, slightly less unsafe is monumentally important. Harm reduction accepts that people will make risky choices and tries to keep them alive long enough to make better ones. Plot twist. Sometimes your Bromazolam isn't even Bromazolam. Sometimes it's Bromazolam plus fentanyl, the synthetic opioid that's killed hundreds of thousands. Why would dealers mix them? Because fentanyl is cheap, potent, and adds a euphoric element that benzodiazepines lack. The combination is called a downer cocktail, and it's incredibly profitable for dealers and catastrophically dangerous for users. Fentanyl is measured in micrograms, millionths of a gram. A dose equivalent to a few grains of salt can kill. Dealers mixing street drugs rarely have precision equipment. They eyeball it, mix it poorly, and create pills where one contains a safe amount and the next contains a lethal dose. Users think they're taking their regular anxiety medication and end up in cardiac arrest. This is why overdose deaths have skyrocketed. It's not that more people are using drugs. It's that the drug supply is contaminated with ultra-potent opioids. Every street pill is potentially Russian roulette. Fentanyl test strips can detect it, but most people don't use them. They trust their dealer. Big mistake. Trust is how people die. The economics of fentanyl contamination are ruthlessly simple. Fentanyl is extraordinarily cheap to produce synthetically. A kilogram costs a few $1,000s and contains enough doses to supply thousands of users. By weight, it's far more cost-effective than heroin or pharmaceutical opioids. Dealers discovered they could stretch their product by adding tiny amounts of fentanyl to create more powerful effects with less actual drug. Initially, this contamination appeared in heroin supplies. Users sought opioid highs, and fentanyl delivered more intensity per dollar, but the practice spread to other drugs, cocaine, methamphetamine, and crucially benzodiazepines. Why contaminate benzodiazepines with fentanyl? Several reasons. First, cross-contamination in labs that press multiple types of pills. A dealer uses the same equipment to press fentanyl-laced heroin pills and bromazolam pills without cleaning between batches. Residual fentanyl contaminates the benzodiazepine batch. Second, intentional adulteration to create stronger effects. Benzodiazepines provide sedation and anxiety relief, but minimal euphoria. Adding fentanyl creates a more pleasurable high, potentially increasing customer satisfaction and repeat business. Third, simple error or ignorance. Some dealers genuinely don't understand the dangers of mixing these substances. They think they're improving their product, unaware they're creating lethal combinations. The physiological interaction between benzodiazepines and opioids is synergistically deadly. Both drug classes suppress respiration through different mechanisms. Opioids bind to mu-opioid receptors in the brainstem, directly inhibiting the respiratory drive. Benzodiazepines enhance GABA activity throughout the central nervous system, including respiratory centers. Combining them creates a double assault on breathing. The brain's ability to maintain adequate respiration collapses, blood oxygen levels plummet, carbon dioxide accumulates. And the person, heavily sedated by both drugs, doesn't wake up gasping for air. They just stop breathing and die quietly. The fentanyl contamination problem reached epidemic proportions in the late 2010s. Overdose deaths in the United States exceeded 70,000 annually by 2017, with synthetic opioids like fentanyl responsible for the majority. But focusing solely on opioid users misses a crucial point. Benzodiazepines were detected in roughly 30% of opioid overdose deaths. The synergy between drug classes turned manageable opioid doses into fatal overdoses. And the reverse is true. Users seeking benzodiazepines who unknowingly consume fentanyl-contaminated pills face opioid overdoses they never intended to risk. Fentanyl analogues compound the problem. Chemists create variations like carfentanil, an elephant tranquilizer 100 times more potent than fentanyl, or acetylfentanyl, furanylfentanyl, and dozens of other analogues. Each new analog slips through scheduling regulations temporarily and creates new forensic challenges. Medical examiners must test for dozens of possible fentanyl variants to determine cause of death. Standard drug tests miss novel analogues. The moving target of designer opioids makes contamination detection nearly impossible without sophisticated laboratory equipment. The street-level reality is horrifying. Users have no way to visually distinguish contaminated pills from clean ones. A pill containing only bromazolam looks identical to one containing bromazolam and fentanyl. The only detection method is fentanyl test strips, immunoassay strips that react to opioid presence. But using test strips requires pre-planning, purchasing strips, and dissolving portions of pills to test before consumption. In practice, most users skip testing. They trust their source, rely on luck, or simply don't know testing is possible. This ignorance and overconfidence kills people daily. Naloxone availability has increased dramatically as public health responses to the opioid crisis expanded. Many states allow pharmacists to dispense naloxone without prescriptions. Harm reduction organizations distribute it freely. First responders carry it universally. Naloxone can reverse opioid overdoses within minutes, restoring breathing and consciousness. But its effectiveness is limited in benzodiazepine-opioid combinations. Naloxone reverses the opioid component, but benzodiazepine-induced respiratory depression continues. Someone might regain consciousness temporarily, then slip back into unconsciousness as the naloxone wears off and benzodiazepine effects persist. Multiple naloxone doses might be required. Medical supervision is essential. The contamination crisis highlights the dangers of prohibition-based drug policies. When substances are illegal and unregulated, quality control is non-existent. Users cannot verify what they're purchasing. Pharmaceutical-grade medications have consistent dosing and purity because regulations enforce quality standards. Street drugs have no such protections. Contamination, adulteration, and mislabeling are rampant. The solution isn't more aggressive enforcement that hasn't worked in 50 years of drug war. The solution is regulated access to pharmaceutical-grade substances for people who will use them regardless of legal status, combined with comprehensive addiction treatment and mental health services. But those policy changes face enormous political obstacles, so the contamination continues and the body count rises. The phenomenon of drug-induced amnesia extends beyond individual incidents into patterns that reshape identity and self-perception. People who regularly use Bromazolam and experience frequent blackouts begin losing continuity in their own life narratives. Memories aren't just individual experiences, they're the threads that weave our sense of self. When those threads regularly vanish, personal identity fragments. You become a collection of disconnected moments rather than a coherent story with past, present, and future. Friends and family members describe a disturbing phenomenon, having important conversations with someone who was present, engaged, and apparently attentive, only to discover days later that the person has zero recollection of the discussion. Plans were made, commitments given, emotions shared, all erased. This creates profound relational damage. Trust requires memory. If someone consistently fails to remember shared experiences, meaningful relationship becomes impossible. You can't build intimacy with someone whose consciousness regularly vanishes into chemical oblivion. The employment consequences are severe. Jobs require memory. Remembering instructions, training, conversations with supervisors, commitments to colleagues. Someone experiencing regular benzodiazepine amnesia shows up to work meetings they don't remember scheduling. They fail to complete tasks they don't remember accepting. Co-workers repeat information that was supposedly covered. Performance reviews document concerns about reliability and attention. Eventually, termination follows. And throughout this, the person genuinely doesn't understand what's happening. From their perspective, they're trying their best, but reality keeps glitching in ways they can't explain. Medical professionals face diagnostic challenges with patients presenting with amnesia. Is this benzodiazepine-induced? Early onset dementia? Traumatic brain injury? Dissociative disorder? The differential diagnosis is complex, and patients using street drugs might not disclose that information to doctors. They fear judgment, legal consequences, or having pain medications denied. So they describe memory problems without mentioning drug use, and physicians investigate expensive neurological causes while the actual culprit remains hidden. The psychological impact of waking with missing time is genuinely traumatic. Imagine going to bed at 10 p.m. and waking at 6 a.m. with text messages time-stamped at 2 a.m. that you have no memory of sending, or discovering photos on your phone of places you don't remember visiting, or finding purchases in your transaction history that you don't recognize. The experience induces paranoia and dissociation. You start questioning your own sanity. Did I have a psychotic break? Am I developing schizophrenia? The reality that you took a drug that temporarily disabled memory formation might be obvious to observers, but isn't obvious to you if you've normalized Bromazolam use and don't connect it to amnesia. Some users describe a permanent sense of temporal dislocation even after quitting. They look back at years of regular use, and entire periods of their lives exist only as fragments and second-hand accounts from others. They know intellectually that events occurred, other people describe them, photographic evidence exists, but they have no first-person experience of those events. It's like reading about someone else's life in a book written about you. The emotional disconnection from your own past creates existential dread. What does it mean to be a person if you can't remember being that person? Recovery from benzodiazepine dependence often includes confronting this accumulated memory loss. People in treatment describe grief over lost time, months, or years that vanished into chemical amnesia. They can't get that time back. Those experiences, whatever they were, are gone forever. Children grew up during those years, relationships evolved, life progressed. But the person's consciousness was offline intermittently, recording only fragments. Recovery means building a new life narrative that acknowledges these gaps rather than pretending they don't exist. The international nature of research chemical distribution creates jurisdictional nightmares for law enforcement. A user in Ohio orders Bromazolam from a website hosted in the Netherlands, operated by a vendor in Poland who purchases powder from a manufacturer in China, who ships through Singapore to avoid customs scrutiny. Which country's laws apply? Who has jurisdiction to prosecute? International drug treaties exist, but enforcement requires cooperation between multiple nations with different priorities, resources, and legal systems. The result is a diffusion of responsibility where everyone's responsible, and therefore no one is responsible. Prosecuting users is largely pointless and counterproductive. Someone caught with a few pills of Bromazolam might face charges in jurisdictions where it's scheduled, but conviction results in minor penalties, fines, probation, maybe short jail sentences. These penalties don't reduce demand. They push people deeper into criminal networks, create barriers to employment and housing, and exacerbate the social marginalization that drives drug use in the first place. Progressive prosecutors increasingly decline to pursue possession charges for small quantities, recognizing that criminalizing addiction doesn't solve addiction. Prosecuting vendors is more impactful but extraordinarily difficult. Darknet vendors use sophisticated operational security, VPNs, encrypted communications, cryptocurrency tumblers, dead drops for physical products. They compartmentalize operations so no single person knows the full supply chain. When law enforcement manages to arrest one vendor, they've eliminated a single node in a decentralized network. The market adjusts within hours. Other vendors absorb the lost customer base. New vendors emerge. The underlying infrastructure persists. Some jurisdictions have experimented with analog scheduling by class rather than by individual compound. The United Kingdom's Psychoactive Substances Act bans production and distribution of all psychoactive substances except those explicitly exempted. This closes loopholes proactively. Any new substance is illegal by default until proven safe. But even this approach has limitations. Enforcement requires proving a substance is psychoactive, which demands scientific testing. Manufacturers claim their products aren't psychoactive or are intended for non-psychoactive uses. Legal battles ensue over chemical definitions and pharmacological evidence. China's approach to regulating research chemicals has evolved significantly. For years, Chinese law regulated only specific scheduled compounds, leaving analogues legal. This created the phenomenon of Chinese labs openly supplying global designer drug markets. But international pressure, particularly from the United States, prompted regulatory changes. In 2019, China scheduled all fentanyl analogues as a class. Production and export plummeted overnight, demonstrating that Chinese authorities can effectively control chemical manufacturing when politically motivated. But extending this approach to all designer drugs faces obstacles. China's chemical industry is economically significant, employing millions and generating billions in revenue. Blanket restrictions impact legitimate pharmaceutical manufacturing and research. The fundamental problem isn't legal frameworks, it's the game theory of prohibition. Creating a new designer drug is relatively easy for competent chemists. Manufacturing it is scalable and profitable. Distribution through darknet markets is low risk compared to traditional trafficking. Demand is steady because human beings seek substances that alter consciousness and alleviate suffering. As long as these factors remain true, designer drugs will proliferate regardless of legal status. Scheduling Bromazolam might reduce its availability temporarily, but users will switch to the next analog within weeks. The substance changes, the behavior doesn't. Some policy experts advocate for regulated legal access to psychoactive substances as the only realistic solution. Portugal decriminalized personal drug possession in 2001, and invested savings from reduced incarceration into treatment services. Drug use didn't spike. Overdose deaths declined dramatically. Switzerland pioneered heroin-assisted treatment, providing pharmaceutical-grade heroin to chronic users in supervised settings. Crime dropped, health outcomes improved, and many users eventually transitioned to abstinence. These models acknowledge that prohibition creates more harm than the substances themselves. Regulated access ensures quality control, eliminates contamination risks, and connects users with health services. But American drug policy remains rooted in prohibition and punishment, despite decades of evidence that this approach fails. The political economy of drug war, law enforcement budgets, private prison profits, political rhetoric about being tough on crime creates powerful constituencies opposed to reform. Meanwhile, people continue dying from contaminated street drugs that exist only because prohibition eliminates regulated alternatives. The legal status of Bromazolam is ultimately a symptom of this broader policy failure. As long as we treat drug use as a criminal justice issue rather than a public health issue, new substances will keep slipping through cracks while people keep dying from contamination, overdose, and lack of access to evidence-based treatment. Let's talk about what happens when you take Bromazolam regularly for months or years, because the long-term effects are genuinely horrifying. First, cognitive impairment. Chronic benzodiazepine use is associated with memory problems, difficulty concentrating, and slower processing speed. Your brain essentially becomes foggy permanently. Studies show this can persist even after stopping, especially in older adults. Second, emotional blunting. Long-term users report feeling disconnected from emotions. Not depressed exactly, just flat. Colors seem less bright, joy less joyful, sadness less sad. You become a dulled version of yourself. Third, increased risk of dementia. Recent research suggests long-term benzodiazepine use may increase Alzheimer's risk, though causation is still debated. Your brain physically changes structure with chronic use. GABA receptor density decreases, requiring ever higher doses for effect. Fourth, physical health consequences. Chronic sedation leads to weight gain, decreased mobility, higher fall risk, broken bones, and social isolation. And fifth, the psychological trap. After months of chemical anxiety management, your brain forgets how to cope naturally. Stopping means not just withdrawal symptoms, but also confronting anxiety that's now worse because your coping skills atrophied. It's a neurological prison where the key is a slow, painful taper that many never complete. The neuroscience of chronic benzodiazepine exposure reveals progressive adaptations that undermine normal brain function. GABA A receptors, constantly bombarded by benzodiazepine enhancement, undergo structural changes. Receptor subunit composition shifts. Certain subtypes become less responsive while others upregulate to compensate. The net effect is tolerance, more drug required to achieve the same effect, and dependence. Normal brain function impossible without the drug. These changes occur at the molecular level in neuronal membranes throughout the brain, affecting not just anxiety circuits but memory systems, motor control, and executive function. Cognitive decline manifests in multiple domains. Verbal memory suffers, difficulty learning new names, forgetting conversations, losing track of what you were saying mid-sentence. Visual spatial processing slows, trouble navigating familiar places, difficulty assembling objects, reduced coordination. Executive function deteriorates, problems with planning, organization, multitasking, and decision-making. Processing speed decreases universally. Everything takes longer to think through, understand, and respond to. These deficits accumulate gradually, so users often don't recognize them as drug-related. They attribute memory problems to aging, stress, or insufficient sleep, rather than connecting them to chronic benzodiazepine use. The emotional numbing described by long-term users is particularly distressing. Emotions require neurological dynamism, the ability to shift between states, respond to stimuli, experience ranges from sadness to joy. Benzodiazepines flatten this responsiveness. The same mechanism that reduces anxiety also reduces all emotional reactivity. Over time, users describe feeling like they're watching life through a window rather than participating in it. Happy events don't feel happy. Sad events don't feel sad. Everything exists in a grey middle zone of mild sedation and emotional absence. Relationships suffer because emotional connection requires emotional presence. How do you love someone when you can't feel much of anything? The dementia link remains controversial but concerning. Several large epidemiological studies found associations between long-term benzodiazepine use and increased Alzheimer's risk. A 2014 French study suggested 30 to 40% increased risk with chronic use. Other studies found similar patterns. However, causation is difficult to establish. Do benzodiazepines cause dementia, or do people with early cognitive decline use benzodiazepines more? The neurological plausibility is there. Chronic GABA enhancement disrupts synaptic plasticity necessary for learning and memory. Accumulating tau protein and amyloid plaques, hallmarks of Alzheimer's, might be facilitated by long-term receptor changes, but definitive proof requires controlled trials that would be unethical to conduct. Physical health deteriorates through multiple pathways. Sedation reduces activity levels. Users spend more time lying down, sitting, avoiding exercise. This leads to muscle atrophy, weight gain, cardiovascular deconditioning, and metabolic syndrome. Falls become more common. Benzodiazepines impair balance and coordination, especially in older adults. Hip fractures from falls can be fatal in elderly populations. Recovery requires rehabilitation that's complicated by continued drug use. Social isolation follows from cognitive impairment and emotional blunting. Maintaining friendships requires memory, emotional engagement, and initiative, all compromised by chronic benzodiazepine exposure. Users gradually withdraw from social activities, exacerbating depression and anxiety. The catch-22 of long-term use is that stopping becomes harder the longer you've used. Tolerance means you're taking high doses just to maintain baseline function. Withdrawal from high doses is more severe and prolonged. The anxiety that prompted initial use has often worsened from chronic drug exposure. Stopping means confronting not only withdrawal symptoms but also rebound anxiety more intense than original symptoms. Many users attempt to quit, suffer through weeks of agony, then relapse, because the psychological distress becomes unbearable. They convince themselves they need the medication to function, even though the medication is causing the very dysfunction they're trying to escape. Some long-term users describe a phenomenon called tolerance withdrawal, experiencing withdrawal symptoms while still taking the drug. This occurs when receptor adaptation progresses to the point where even continued use doesn't maintain baseline function. You're taking high doses but still feeling anxious, shaky, and dysphoric because your brain has adapted beyond the drug's ability to compensate. At this point, users are trapped in a pharmacological nightmare. Taking the drug provides no benefit, but stopping triggers severe withdrawal. The only escape is a carefully managed medical taper that might take months or years. Recovery from chronic benzodiazepine use requires not just physical detoxification, but cognitive rehabilitation. Memory and concentration improve gradually after cessation, but recovery is slow and incomplete. Some deficits persist permanently. Emotional reconnection takes time. Users describe months of emotional flatness after quitting, before feelings begin returning. Physical health recovers through exercise, nutrition, and time. Social connections must be rebuilt deliberately. The process is long, difficult, and requires support systems many chronic users lack. But recovery is possible. Brains have remarkable plasticity. Given time and appropriate conditions, many functions restore themselves. Not everyone fully recovers, but most improve significantly compared to their state during chronic use. TikTok, Instagram, Reddit. These platforms are accidentally creating drug epidemics by making substance use look casual, fun, and consequence-free. Bartered stories where people share blackout experiences on Xanax get thousands of likes. Harm reduction subreddits inadvertently normalize dangerous use by providing guides on how to safely take substances that aren't safe by definition. Influencers post aesthetically pleasing photos of pills like they're posting brunch. Comment sections become how-to guides. Where do I buy Bromazolam? What's a good starter dose? Can I take this with alcohol? Teenagers and young adults see this content and internalize that everyone's doing it. It's not that dangerous. And problems only happen to people who are stupid about it. Algorithm amplification means someone researching anxiety relief gets fed content about self-medicating with research chemicals. The platforms claim to ban drug content, but enforcement is inconsistent. Coded language slips through. People talk about bars, benzos, RC, research chemicals without triggering content moderation. And when someone does overdose or have a bad experience, that content gets less engagement than the funny blackout stories, so the algorithm suppresses it. The feedback loop creates perception that designer drugs are low risk, high reward, which is catastrophically false. Social media hasn't just changed how drugs are distributed, it's changed how they're perceived, and perception shapes behavior. The aestheticization of drug use on visual platforms like Instagram creates aspirational associations. Pills are photographed with artistic lighting, arranged on aesthetically pleasing surfaces, paired with designer fashion or luxury goods. The imagery communicates that drug use is sophisticated, edgy, part of a desirable lifestyle. This is particularly effective with younger audiences who are developmentally primed to seek peer approval and social status. When influencers with large followings normalize substance use, they create powerful social proof that shapes attitudes and behaviors in their audience. Reddit's drug forums operate under a harm reduction framework that's well-intentioned but has unintended normalizing effects. Subreddits like R, benzodiazepines, or R, research chemicals provide information about dosing, combinations, testing, and experiences. The stated goal is keeping people safe. But the net effect is providing a comprehensive guide to using dangerous substances. Someone curious about Bromazolam can find detailed trip reports, vendor recommendations, dosing charts, and advice on avoiding detection, everything needed to begin use. The community atmosphere is supportive and non-judgmental, which lowers psychological barriers to experimentation. Users rationalize that they're being smart about drug use by researching thoroughly, not recognizing that research validates the decision to use rather than deterring it. The Bartard Stories phenomenon illustrates how traumatic experiences get reframed as entertainment. Users share stories of blackout behavior, waking up in jails, hospitals, or strange locations with no memory of how they got there. These stories are told with humor and self-deprecation, framed as wild adventures rather than narrow escapes from death or serious injury. The comments are filled with laughter emojis and same bro responses. This reframing sanitizes the reality of benzodiazepine amnesia and makes dangerous behavior seem like a rite of passage. Young people reading these stories don't see the trauma. They see social currency and inclusion in a subculture. Algorithm-driven content recommendation creates filter bubbles that reinforce drug use. Someone who watches one video about Xanax will be recommended dozens more. The algorithm optimizes for engagement, and drug content is highly engaging, provocative, taboo, emotionally resonant. Users fall down rabbit holes where their entire feed becomes drug-related content. This creates a distorted perception of prevalence. If half the content you see relates to drug use, it seems like half the population uses drugs. Reality is very different, but algorithm-curated reality becomes subjectively real. Platform moderation faces impossible challenges. Automated systems flag obvious drug content, posts containing heroin for sale, or explicit drug imagery. But users adapt with coded language. Presses instead of pressed pills, pharmaprams for Mexican Xanax, emoji codes, certain combinations represent specific drugs without triggering content filters. Moderators play whack-a-mole with evolving slang. By the time one set of terms is banned, new ones have emerged. And legitimate harm reduction content gets caught in enforcement. Posts about naloxone distribution or testing supplies are flagged alongside drug sales. Platforms struggle to distinguish education from promotion. The lack of negative content creates selection bias. People post about their enjoyable drug experiences, but rarely about overdoses, addiction, or long-term consequences. Those aren't fun to share and don't generate engagement. When someone does post about problems, the algorithmic feed suppresses it because negative content gets less engagement than positive content. Users scrolling their feeds see hundreds of Xanax was amazing posts, and maybe one Xanax ruined my life post. The skewed representation creates false confidence that positive outcomes are typical and negative outcomes are rare exceptions. Influencer marketing has entered drug culture. Some influencers subtly promote substances without explicitly advocating use. They post photos with pills visible in the background. They make references in captions that followers recognize. They don't say you should try this, but the implication is clear. These influencers sometimes have financial relationships with vendors, affiliate links, sponsorships, disguised as personal recommendations. Followers trust influencer recommendations and imitate influencer behaviors. If someone they admire uses Bromazolam, it becomes aspirational. The solution isn't more censorship that drives content to less visible platforms where harm is greater. The solution is counter-messaging. Public health campaigns on social media that are honest, non-judgmental, and credible. Harm reduction organizations with active social media presence providing accurate information. Algorithm changes that prioritize educational content over sensational content. Influencer partnerships, where people with large platforms talk honestly about addiction, overdose, and recovery. And media literacy education, teaching young people to critically evaluate social media content and recognize when they're being manipulated. Social media won't stop being a vector for drug normalization. That ship has sailed. But it could become a vector for education and harm reduction instead. The technology is neutral, the content isn't. We need to populate these platforms with information that saves lives, rather than ceding the space entirely to content that ends them. So here we are, at the end of another journey through the darker corners of human chemistry and desperation. You've spent the last few hours learning about Bromazolam, a substance that didn't ask to exist, created by researchers who shelved it decades ago, only to have it resurrected by underground chemists who saw profit in other people's anxiety. It's a story that's equal parts tragedy and cautionary tale, wrapped in the absurdity of a world where you can order potentially lethal chemicals with less verification than buying a book. Tonight, you've walked through the entire life cycle of a designer drug, from Chinese laboratories operating in legal grey zones, through darknet markets encrypted and anonymous, into counterfeit pills pressed in clandestine operations, and finally into the bodies of people who thought they were just trying to manage their anxiety or get some sleep. You've seen how Bromazolam slips past regulators playing an eternal game of chemical whack-a-mole. You've learned how it binds to GABA receptors in your brain, turning down the volume on anxiety but also on memory, coordination, and eventually breathing itself. You've understood why people choose it, because healthcare is expensive, doctors are reluctant to prescribe benzodiazepines, and street alternatives are cheap and readily available. And you've witnessed the consequences. Addiction that develops within weeks, withdrawal that can literally kill you, overdoses that happen when pills contain unknown doses or deadly combinations, and memory blackouts that erase hours of your life as if they never happened. The people using Bromazolam aren't villains. They're not moral failures or cautionary tales designed to make you feel superior about your life choices. They're human beings suffering from anxiety disorders, panic attacks, insomnia, trauma, and all the psychological pain that comes with being alive in the 21st century. They're people who fell through the cracks of a healthcare system that's too expensive, too slow, too judgmental, or too overwhelmed to help everyone who needs it. They're self-medicating because the alternative is suffering, and when you're drowning in your own mind, you grab whatever lifeline appears, even if it's a rope that might strangle you. The dealers selling Bromazolam aren't cartoon villains twirling mustaches either. Some are, sure, sociopaths profiting from human misery without a shred of conscience. But many are just links in a supply chain they don't fully understand, selling what they believe is Xanax to people who desperately want it, unaware that they're distributing research chemicals mixed with fentanyl, in doses that vary wildly from pill to pill. They're capitalists in an unregulated market, operating by the same supply and demand principles as legitimate businesses, just without safety regulations, quality control, or any accountability when things go wrong. And the chemists creating these substances, they're not mad scientists cackling in laboratories. They're often legitimate researchers or skilled technicians who understand that tweaking molecules creates compounds that slip through legal definitions. Some genuinely believe they're serving a harm reduction purpose, providing alternatives to pharmaceutical drugs that are price gouged or restricted. Others are purely mercenary. They make substances people want, collect payment, and don't think too hard about what happens after the product ships. The morality is complicated, the consequences less so. What's truly disturbing about the Bromazolam story is how utterly preventable it all is. Not through more aggressive law enforcement. 50 years of drug war have proven that approach fails spectacularly. But through basic policy changes that most developed nations refuse to implement: accessible mental health care, affordable prescription medications, harm reduction services including drug checking and supervised consumption, treatment on demand for anyone struggling with addiction, decriminalization of personal drug possession so people aren't afraid to seek help, regulated access to pharmaceutical-grade substances for people who will use them regardless of legal status. These solutions exist. Evidence supports them. Countries have implemented them successfully. Portugal decriminalized drugs and saw overdose deaths plummet. Switzerland provides heroin-assisted treatment and reduced crime while improving health outcomes. Canada offers supervised injection sites that save lives daily. The obstacles aren't scientific or even economic. They're political. It's easier to fund police than treatment. It's more popular to be tough on crime than compassionate toward people society views as making bad choices. It's simpler to ban substances than to address why people desperately seek them. So we're left with Bromazolam and dozens of analogues like it, flowing through markets that exist because prohibition creates them, killing people who might have lived if they'd had access to regulated alternatives and evidence-based care. We're left with families mourning loved ones who overdosed on pills they thought were something else. We're left with people trapped in addiction to substances they didn't know they were taking, facing withdrawal so severe it could kill them. We're left with emergency rooms overwhelmed by overdoses, morgues processing bodies contaminated with unknown chemicals, and communities devastated by a crisis that was designed into existence by failed policies. But here's what you need to understand. This isn't just about Bromazolam. It's about the future of drugs in general. The technology for creating designer substances is democratizing. Information spreads freely online. Equipment is cheap and readily available. Within your lifetime, synthesizing custom pharmaceuticals at home might be as accessible as brewing coffee. At that point, every policy based on prohibition becomes obsolete. You can't ban what anyone can make in their garage. You can't intercept what's produced domestically. You can't arrest your way out of a problem that exists in millions of homes. The future is either harm reduction, meeting people where they are, providing information and resources to keep them alive, treating addiction as a health issue rather than a criminal one, or it's escalating carnage. There's no third option. We can continue the current approach and watch overdose deaths climb year after year. Or we can acknowledge that humans have used psychoactive substances for thousands of years, will continue using them regardless of laws, and deserve access to accurate information, quality-controlled products, and compassionate care when things go wrong. If there's one thing you take away from tonight's journey through the world of Bromazolam, let it be this: the people dying from designer drugs are not statistics. They're not cautionary tales. They're not moral lessons about the dangers of drugs. They're human beings who deserved better healthcare, better options, better support, better drug policy, better everything. They deserved to live in a world where seeking relief from psychological pain didn't require gambling with their lives. So tonight, as you lie in your comfortable bed, maybe think about them. The people who took a pill thinking it would help and woke up in hospitals, or didn't wake up at all. The families destroyed by overdoses that were entirely preventable. The people trapped in addiction to substances they never chose, suffering through withdrawal that feels like dying. The young people whose lives are just beginning, scrolling through social media where drug use is normalized and glamorized without any honest discussion of consequences. Think about them, and maybe, if you're in a position to influence policy or culture, or even just conversations with people who need help, remember that compassion costs nothing and saves everything. The story of Bromazolam is still being written. New chapters add themselves daily. More overdoses, more contaminated pills, more people discovering too late that what they thought was safe was anything but. The ending hasn't been written yet. It could be a future where designer drugs become a permanent, manageable reality with robust harm reduction and accessible treatment. Or it could be a future where the body count just keeps climbing while we repeat the same failed policies, expecting different results. Which future we get depends on choices we make now, as individuals, as communities, as a society. You can't solve the designer drug crisis alone. But you can be informed, compassionate, and honest. You can support harm reduction. You can advocate for treatment over incarceration. You can talk openly about drugs without judgment or moralizing. You can keep naloxone nearby and know how to use it. You can check on people you care about. You can recognize that just say no has never worked and never will, and that real solutions require nuance, empathy, and resources. Bromazolam is just one substance in an ever-expanding catalogue of designer drugs. By the time it's fully scheduled and banned, 3 more analogues will have taken its place. The game never ends. But maybe that's not the point. Maybe the point isn't winning the war on drugs, because that war was lost before it began. Maybe the point is minimizing harm, keeping people alive, and building a world where suffering doesn't automatically push people towards substances that might kill them. So sleep well tonight if you can. Dream of a world where mental health care is accessible and affordable, where people in pain have options that don't involve chemical Russian roulette, where addiction is treated as illness, not moral failure, where drug policy is based on evidence rather than politics, where lives matter more than ideology. That world is possible. It just requires us to care enough to build it. Sweet dreams. And remember, if you or someone you know is struggling with substance use, help exists. It's imperfect, often hard to access, and not always adequate, but it exists. Treatment works. Recovery is possible. People quit drugs successfully every single day. You're not alone, you're not broken beyond repair, and you deserve support without judgment. Now, rest. Tomorrow's another day, another chance, another opportunity to be kinder to yourself and others navigating this messy, complicated, often painful existence we call life. Good night.